Hello, everybody. I'm Ellen Gwynn, and we're ready to get this Soil Health Research Forum 2020 underway. I wanted to welcome you all to this event, and so pleased that you were able to join us today. It's a real honor to have all these various researchers come and join together in this virtual event. We can't be together as we would normally be together to celebrate this World Soil Health Day, but we can be together virtually. So thank you. I'm Ellen Gwynn, and I am a research analyst at OMAFRA. And I've cared a lot about soil health for a long time. Back in the day, Soils at Risk was a key document in my life. And that's when as it falls down to the floor, that's when my interest in soil health started. I want to welcome you all today, and we've had a long involvement in soil health at the ministry, and my personal interest goes back a long time too. So soil health is also becoming mainstream. It was on the CBC a week ago on Sunday Magazine. They featured Dr. Ratan Lal talking about the importance of soils and clean soils and healthy soils as important as clean air and clean water. And that was pretty exciting to see that on mainstream radio. So today's event is going to share some of the major contributions of soil health research funded under the University of Guelph OMAFRA partnership known as the Alliance, as well as OMAFRA funded research. But before we begin, I want a few housekeeping rules. And you can see along the bottom the chat. My colleague Tegan has added some items to the chat to let you know what Twitter we're using, that we're recording this event, that we're going to, there's continuing education points under CCA, and that we want you, if you have any chat issues, to put them in the chat. But the questions for the researchers, we want to put it under the Q&A along the bottom, you'll see that. So those for the questions for the presenters will go there. And the questions for any other type of questions will go there. Then my colleague Tegan can help us with those. Great. So today, I will be the host for 2 sessions, and then my colleague Cam Ogilvie from Soils at Guelph will be the host of the 3rd session. If there's any technical issues from my end, let's say slow internet or whatever, Nicole Rabe from OMAFRA will pop in. And if all goes well, we're going to have 2 short breaks between sessions, but it all depends on how many great questions we have or all the great presentations from our researchers. But our goal is to have 2 short breaks. Just want to make sure I've covered all the logistics that I'm supposed to cover. And I hope everybody can see me and hear me still. So I imagine most of us are here today because we care about the soil. We care about the land, on the health of the soil, the productivity, and the agri-food jobs, as well as contributing to the food for consumers. The connection point for all of us today is soil and finding the best practice to keep the soil healthy. So today's event, I'll start now with a land acknowledgement. To recognize the land is an expression of gratitude and appreciation to all those who have been living and working on the land from time immemorial. It is important to understand the long-standing history that has brought you to reside on the land and to seek to understand your place within history. Today, I'm located in Guelph, Ontario, so I will do the land acknowledgement as if I'm from Guelph, but you can do it from any other part of the world, part of the continent that you're on. We have some guests coming from the US and from other provinces outside of Ontario, as well as across Ontario. Guelph is situated in Treaty 3, which is known as Between the Lakes Treaty, on the ancestral homelands of the Anishinaabe people, specifically the traditional territory of the Mississaugas of the Credit First Nation. This land is also ancestral land of the Attawandaron people. Today we recognize and honor our Anishinaabe, our Haudenosaunee, our Métis, and Inuit neighbors who currently call Ontario their home. Guelph is in the dish with one spoon territory. The dish with one spoon is a treaty between the Anishinaabe and the Haudenosaunee that bounds them to share the territory and protect the land. We can consider how we are also bound to protect the land. The sharing and protecting the land approach is one that we can all participate in. So wherever you're located, please, I encourage you to seek out the Indigenous history of your area. And now, to begin our forum, you won't be able to see the participants of this forum, but I want you to know that over 300 people registered, and currently there are 181 participants attending this event right now. And we have a few polling questions for you to answer. So my colleague Tegan will put those polling questions up so you can see them, and you can start filling that out as I introduce our first speaker. So Tom Haggerty, Tom, you're welcome to turn on your webcam. Before we start with our keynote presentation, Tom Haggerty, the Director of Environmental Management Branch of OMAFRA and the Director Champion of Stewardship Research Priority will be here to provide some opening remarks. Please join me in welcoming Tom.
Hello, everybody. And can I just confirm that you can hear and see me properly?
Absolutely.
Okay, that's good. So first of all, thank you for the invitation to introduce today's session. I think this is going to be a really excellent opportunity, and we've got a really strong participation, which is usually a sign of the strong interest that's out there. So as Ellen was saying, I've got two roles in the ministry. One is Director of Environmental Management Branch, but I also serve as OMAFRA's Director Champion for Environmental Stewardship and Soil Health Research. And this research is an absolutely critical underpinning to our environmental focus in the ministry. I think often it's convenient to think about soil health and water quality and air quality as separate things, because it allows us to focus on specific aspects of the environmental performance. But really, they're all different aspects or different facets of the same gem. And so the ministry's stewardship activities have several key areas of focus. And one important one is about changing the behavior of industry participants to achieve a smaller environmental footprint. And when you're trying to seek to influence or nudge agricultural practice, it really does require more than just technical knowledge. It requires insights into the science of behavior and what motivates us to change. And you'll see in today's agenda that there's an area of research, an area of this research that's a real interest for the ministry, and it's reflected in some of the agenda today and some of what you'll be hearing. Certainly understanding the economics of stewardship is also important because economic sustainability for the sector and environmental sustainability for the sector tend to be flip sides of the same thing. And in the sector, in the agri-food sector, quite often the economics is probably one of the key determinants of whether or not people are willing to take the risk of changing their practice. So another key area of focus in our research agenda is strengthening our ability to understand and quantify the relationship between agricultural practice and a wide range of environmental impacts of soil, water, and air. And we're obviously focused today on soil, but as I've said, the others are all related to that as well. And this understanding is at the base of our policy and program development in the ministry. So this is really critical for our understanding. And the government's ability to monitor and measure environmental impacts and outcomes was also the focus, excuse me, was also the focus of a recent Auditor General of Ontario report that's just come out in the last few weeks. And you will see that environmental science and the understanding of the relationships between agricultural practice and the outcomes, environmental outcomes, are also strongly reflected on today's agenda. And the last thing I'll just say is that in 2015, OMAFRA invited partners from the agricultural sector, conservation groups, and academia to form a technical soil working group. And the work of this soil working group led in 2018 to the launch of a soil strategy. And in that strategy, it outlines 84 different actions to be completed by 2030. So there's a 12-year planning horizon to this document. but it's comprehensive, and it represents, it maps out a fairly broad territory of challenge that we need to rise to. And again, research is at the underpinning of so much of what we need to achieve in that document. And in fact, the soil strategy itself, if you were to look in it on page 45, you're going to see that there are a page of research priorities for soil health that working group identified. Anyways, so you're going to hear about some of the research that's addressing these priorities in today's forum. And I encourage you to be an active participant and take away from this session insight and thoughts about what you might be able to do to move things forward. Anyways, with that, I'm gonna sign off and turn it back over to Ellen.
Thanks, Tom. That's a wonderful way to get us launched today. And the efforts of the soil health strategy and the soil action group is really making a difference across this province. And also a lot of people have been attending today. So we wanted to thank you, Tom, and for highlighting these. One of the soil strategy items includes a focus on how do we help farmers or decision makers who manage land be aware of what the latest research is and how to adopt practices. So it's really important that we understand about behavior change and how can we help some of the decision making that happens on the land. So to this end, we asked Dr. Jay Arbuckle to join us today. And since we've asked him to join us today to provide insights on behavior change, key insights on behavior to on-farm adoption. So now I'd like to welcome our keynote for today, Dr. Jay Arbuckle, who's from Ohio State University in Ames, and he's professor of sociology. And you can find all the biography information on the link to the website that was about this event that you should have got when you registered. And that's where you see all the biographies for all the speakers today. Thanks very much. Over to you, Jay.
Okay, thank you very much, Ellen. Well, thank you all for having me. This is great. I'm going to go ahead and share my screen. All right, I trust that everybody can see, or at least you can see,
Yep.
Ellen?
Yes, I can see, thank you.
Excellent, great. Well, thanks. So the title of my talk today is Promoting Behavior Change for Soil Health, Insights from Recent Social Science Research. And I'm a professor of rural sociology at Iowa State University, and which is actually, I think, a little bit north of where you all are, or very close to it. So anyway, thank you for having me up north. And I'll just start off by laying out the goals for today's presentation. It's fairly straightforward. What I'd like to do is summarize some findings, or the findings from two recent major reviews of social science research on soil and water conservation practice adoption and non-adoption, and then also kind of use the discussion of the key findings from that research as a segue into a discussion of the ways that agricultural stakeholders can help facilitate more widespread adoption of soil health practices. So there's an awful lot of social science research out there on soil health related practices, particularly on cover crops, no-till, extended rotations, and other related practices. And so I and a number of colleagues several years ago decided that we would like to do kind of a up-to-date review of the social science research out there. And so today I'm going to share with you some key results from two major papers, both published in 2019. The first one was Prokopi et al., Adoption of Agricultural Practices in the US, Evidence from 35 Years of Quantitative Literature. And then the second is Synthesizing Conservation Motivations and Barriers, What Have We Learned from Qualitative Studies of Farmer Behaviors in the US. And so I was a co-author on paper one, and then a supportive kind of co-conspirator in paper two. And so I think we learned an awful lot from the process of putting these together, and so I'm really excited to share some of the results. Just real quick, the kind of the basic methods of pulling these two reviews together. We looked at all U.S. farmer adoption, basically it was U.S. farmer adoption of soil and water conservation practices. We identified over 200 articles and set some criteria for inclusion in the study. So we ended up with 107 quantitative adoption studies, which went into paper one. and then 49 qualitative adoption studies into paper 2. And I should just point out that quantitative, when I say quantitative, I mean survey research, so survey research with farmers and landowners, and then qualitative would be research that relies on qualitative methods such as in-depth interviews, focus groups, and so forth. Okay, so today I'm going to talk about some of the major themes from the research. The reviews, both the qualitative and the quantitative, identified what we see as kind of the most consistent predictors of soil and water conservation practice adoption, both negative predictors and positive predictors. And so what I've done is pulled key quotes from selected quantitative and qualitative studies to kind of help me discuss the different themes that have emerged from literature. And I've really focused in, since this is a conference on soil health, I've focused in on the major soil health practices, in particular cover crops, no-till, and extended rotations. And really the guiding question for this presentation are, what are the major barriers to and facilitators of practice adoption, and which is, behavior change. All right, well, we'll dig right into it. So first I'm going to talk about negative predictors or barriers to adoption. And as you all know, there are quite a few of those. Tom mentioned in the outset, the economic barriers are major, and this, one of the first themes that came out of the literature is perceived risks, and in particular, potential yield loss and economic loss associated with that yield loss. And so here are a couple of quotes from some of the key publications. I've never done cover crop. I can see some benefits in it, but when you get looking at the financial end of it, and then in the interim, who's paying for that for the producer and reduction in yields or whatever? This is from a focus group that was done last year or the year before in Indiana. Here's another one. That's the only downfall I see in cover crops. It's going to suck some moisture out. They say it don't, but it does something. And once you get that off in there and it turns out dry, you're hurting. So those are two kind of representative quotes that demonstrate farmers' perceived risks of yield loss. Another major area of perceived risks is timing. This is particularly difficult, or particularly a challenge to larger scale farmers who are really trying to plant and harvest extensive farms with extensive hectares. So there's also, there's a climate change in the upper Midwest, and I'm sure over in Ontario, there's an increasingly short window of time in the spring that you can get things planted, and also in the fall, a short period of time to get things harvested. And so timing has become a really relevant perceived risk. And here are a couple quotes. We've all identified that when you need to put a cover crop on, if it's after harvest, not everybody has that time. Another, I've talked to a lot of the cover crop guys, and if you're going to try it and do it after tillage, our growing season is so short that I don't know what around here is probably going to work. So now I've got to not only address cover crops, but then I also have to address my management, because if I'm going to rip or do any fall tillage, then cover crops doesn't fit in that. And if you're talking about cover crops, it's a timing thing. You get such small windows of time where you can do something that it's a positive thing rather than a negative thing. I don't know how you throw that cover crops into the mix when you're trying to just take care of business. As Tom mentioned at the outset in his introduction, the cost and the economics of conservation practices is a major barrier. And so here are just a couple of quotes that demonstrate that. Just take cover crops as one example. I work for NRCS. I see all the data. I've listened to all the stuff. But then I also look at, okay, it's $30 an acre. That's a big cost. I mean, in my budget right now, it's a big cost. And I should mention the NRCS is the USDA, the United States Department of Agriculture's Natural Resources Conservation Service. So this beginning farmer also is a soil technician for the Natural Resources Conservation Service. So he was highly cognizant of the benefits of cover crops, but really it was really kind of an eye-opener when he shared this about the costs and how that's an impediment. And here's another. Now it's getting cheaper, but what does it cost to establish that cover crop? Well, I got a deal here. We can fly it on for $45 an acre. Well then, what does it cost me to kill it? They've done the math before, and without the incentives, the CSP program, last year's EQIP, last year's State of Iowa incentive programs, it's hard to put the math to cover crop unless you can put a number, a dollar value on that nitrate saved. I'll say some more about that dollar value later on. Another key barrier to adoption is lack of confidence or self-efficacy. Farmers kind of confidence in their capacity to actually do the practice, and then also the perceived effectiveness of the practice. Here's a quote, a second finding was that lower levels of perceived agronomic capacity to implement conservation practices was associated with a lower likelihood of cover crops adoption. In other words, farmers who tended to view nutrient loss reduction as a difficult challenge were less likely to use cover crops. Also, results also revealed that farmers were more likely to already use cover crops if they were more willing to take risks, had more education, greater response efficacy, had more owned acreage, and had a higher sense of control over nutrient loss. So that kind of both response, capacity of the practice to address the resource concern, and also the farmers' capacity to implement the practice. Another is what we call structural factors, like lack of infrastructure. So here's a quote. Many Iowa farmers believe that if more facilitating infrastructure, such as educational, institutional, and technical, were available to them, they would be more likely to use cover crops. In particular, kind of the crop advisors at this time had not been working with cover crops for a long time, so that that knowledge infrastructure was not there. And here's another quote from Gabrielle Resch-McNally paper in 2017. At a structural level, a major factor that may influence adoption of cover crops is the historic and normative trend toward industrial commodity-oriented monoculture systems. Another major structural factor is rented land. I'm not sure what degree of cropland is rented in Ontario, but in the upper Midwest, the most fertile areas, upwards of 70% of the most fertile cropland is rented. And that has led to a lot of farmers expressing that serves as a barrier to their conservation practices. So here's a quote talking about short-term lease arrangements. It's the biggest barrier in my mind. If you're going to keep the land 10 years and you have the organic matter higher and less erosion, adopting conservation practices was worth it. I'm convinced. I think year-to-year leases are a big barrier. Right. I think that's where the biggest rub's going to be, is if your landlord is on this. A lot of them, my mother, I rent some ground from her. The first 3 years I put on cover crops, she says, well, you got some weeds on your own field. How'd your weeds get so bad? Nobody else's looks like that. And this is my own mother. That was actually hilarious. I conducted that focus group, and it brought the house down when he said that. His mother is his landlord, and even she is serving as an impediment to his cover crop use, or at least, critical. So let's move into the positive predictors of soil and water conservation practice adoption. So a number of areas that were identified as facilitators of adoption. Of course, critically, the perceived benefits of practices. If farmers, believe that a practice will have benefits, they will be more likely to adopt them. Here's a quote from one article. Farmers with higher scores on the perceived benefit scale were more likely to have planted cover crops in 2013. Conversely, farmers with higher scores on the perceived risk scale were less likely to have planted cover crops. And I think the cover crops really served as the kicker to get me started thinking differently about really farming in general, and to start thinking about something other than yield. If your soil is gone, there's no point in farming. Even if maybe you're giving up 5 bushels one year, but you could be giving up your entire way of living in short order, 40 years maybe. Another key concept is perceived compatibility. That is, farmers, do they perceive that the practices that are being promoted, the soil and water conservation practices, are compatible with their management systems? So here's one quote. Cover crops compatibility with producers' current farming system was important for every producer who had adopted it. They were using annual ryegrass specifically because they were practicing no-till. Annual ryegrass was seen as beneficial for no-till because of its deep root system. And our findings show that conservation practices should be compatible or perceived to be compatible with farmers' farm management needs, especially in-field practices, e.g. cover crops, that would change farmers' current management strategies. Another kind of emerging theme is systems thinking. There's some cutting edge research that just came out this year by Sarah Church and some colleagues that found that farmers who tend to be kind of holistic systems thinkers and talk in terms of agroecology tend to be more likely to use cover crops in systems with like no-till and other soil health practices such as extended rotations. Here's a quote from her paper. Our results indicate that farmers who had implemented cover crops were thinking about their farms as an interconnected system. These results reflect what has emerged in other research. Conservation adopters have a systems thinking approach to farm management and decision making. And here's another one. I look at it as a system. You've got to do the whole system. You can't nitpick. You've got to manage your nitrogen. You've got to get good soil seed contact because you're planting into a mass of roots sometimes that you need to do everything. Just to do one piece, it doesn't work. They get discouraged and they say it's no good and they're not going to do it anymore. You need to do everything. So that's another quote that demonstrates thinking about the whole system. More positive predictors, supportive landlords. We talked about this, how landlords could be discouraging of conservation practice adoption. And this is a set of quotes about supportive landlords and the importance of having that support. The presence of a supportive landowner or not renting also emerged as a significant factor. Those who consider their landowner supportive of cover crops or who don't rent land are more likely to have larger proportions of their land dedicated to the practice. And again, some landlords are supportive of their renters taking conservation-oriented action on the land and very willing to provide this support through such action as extending the length of their operator's lease to facilitate implementation of conservation practices on their land. Then another area and this was a very important area. So farmers who tend to seek out and use information, especially from the information sources, the actors that they trust for information on both agronomic factors, but also soil and water conservation information, of course, is one of the most consistent positive predictors of soil and water conservation adoption. So here's a few quotes. I tend to look toward university sources and research that you tend to interpret them as being unbiased. You don't necessarily put as much faith in commercially funded research that is promoting their products. It's a little harder to trust even if it maybe is fine research. I tend to think a lot of times I'll look to the university research, University of Illinois, Purdue, sources that you feel are trusted and unbiased. Another trust-oriented quote, trust or lack thereof in sources of information in general or in specific sources of information such as farmers, watershed groups, conservation agencies, and university extension emerged as an important theme that motivated or hindered adoption of conservation practices. And finally, crop advisors indicated that they were most likely to recommend practices associated with soil health, specifically in-field practices such as soil testing, nutrient management, and cover crops, which crop advisors perceived as highly effective and which fit squarely within their functional role of providing operational and tactical advice related to crop production. Now, this is a really important one just because, we've been, the first quote focuses on university research and that last one focuses on more private sector. One of the things we've been seeing in Iowa and the upper Midwest is an increased role of crop advisors, private sector crop advisors in the soil and water conservation promotion effort, and particularly with cover crops, seeing that cover crops and their advisory role in getting cover crops and other soil health practices on the field to really, they tend to be the most trusted advisor of farmers. And if the crop advisors feel comfortable promoting those soil health practices with farmers, it has a major impact. Farms that have diversified systems, particularly if they have livestock, tend to be the ones that are most likely to adopt soil health practices, in particular cover crops. Here's a few quotes. In both models, farmers who plant a greater variety of field crops and have cattle were more likely to use cover crops. And farmers with more diverse cropping systems were substantially more likely to have planted cover crops. Likewise, farmers who reported having livestock were more likely to have adopted the cover crop. And finally, a quote, but you need the livestock to make that work. I mean, they're using a Kura clover cover crop, and when you get clover established, and then third year, you've got to let it recoup so you don't kill the clover out, and they're doing it, but you need livestock. And then another fairly consistent factor in explaining adoption of soil and water conservation practice adoption is awareness of the environmental issues associated with agriculture, concern about soil and water issues, and also a concern about soil health. So you're trying to think ahead and say, how can I make that soil more resilient or able to handle the stresses, whether it's a dry stress or too much rain or something like that, By having that structure and those roots there from the cover crops and holding onto that soil and maybe hold on to more nutrients through the winter. And building tilt in the soil, that's going to be the main thing that a farmer is going to say. Or where's the payback on this? How can I make that soil more resilient or able to handle the stresses? By having that structure and those roots there, holding onto that soil and maybe holding on to more nutrients, if we can keep those loose nutrients out of our water and use them to build organic matter, then it'll be a plus. So talking about both the soil health benefits and the off-farm environmental benefits. Okay, finally, I mean, I could talk quite a bit longer about these, the different findings on positive facilitators of adoption, but I don't have that much time, so I'll just briefly say that, attitudes toward programs and practices, participation in different soil and water conservation programs, of course, are positive factors. Use of complementary practices, for example, no-till seems to be a consistent gateway practice that makes it easier for farmers to use cover crops. And increasingly, we're finding kind of stewardship identity and ethics is looming large as a major positive predictor of soil and water conservation practice adoption. And then another, consistently farm size and income, larger scale operations seem more likely to use cover crops and some other practices. Okay, so I'm just going to take a few minutes to talk about implications of these results for outreach to farmers and land managers. So we talked a little bit about risk earlier as an impediment, and so I think one of the major take-homes is that research and outreach in particular should focus on risk management in addition to benefits. We talk a lot about the benefits of the soil and water conservation practices and soil health in particular, both on-farm and off-farm. And the research consistently shows that farmers understand the benefits of many of the practices, but the perceived risks outweigh the perceived benefits, at least in the short term. So here's a quote that demonstrates that. You're talking about yield. So if you lose 1 year, you have 1 year down, and that's not just a 1 year problem. Let's say it's only 10 bushels that dropped your 10-year average down 1 bushel. So that would be an issue for me because you're doing the cover crop as a risk. Now you're not only getting a risk of investing in the cover crop, now you're also using your yield. So that's not just a 1 year problem, that's a 10-year problem. And that farmer was talking about the relationship between yields and average yield and crop insurance benefits. So taking a hit to yields can take a hit to long-term crop insurance benefits. Another major finding is that farmers prefer incremental change, and don't we all, or at least many of us. So one of the kind of themes that comes out is that we should start small, and remember we talked about the compatibility of practices. Start small and help farmers to trial their different practices. So here's a quote that demonstrates that. I think you have to do it in moderation because we had a farmer that did all these corn acres, and the following farm with fall with ryegrass, and he had a local fertilizer plant spread it to kill it in the spring. But the day they wanted to do it and the day they had to do it was not the day he wanted it done. And that's where his mistake came. And the weather changed and they couldn't get back to it. And when he put his planter in there, everything wrapped around the chain. So that's why I say you have to do things in moderation. And so this was, a farmer that just jumped right in and did it on the whole thing on his whole farm before he and his, cooperative, his supportive crop advisors and cooperative were ready to do the management. So incremental change is important. One of the things we've been finding is that farmers are interested in longer term flexible funding support. I'm not sure what the government the subsidies or cost shares are like up in Canada, but we tend to have like 1 year, 2 year, 3 year cost shares that help farmers to establish a practice. But the reality is that it takes longer often to get comfortable with those practices. So farmers have said things like, I think the cost share has to be available year after year. It can't just be, we'll start you out with 25 acres for 1 year and then you're on your own. Or a hassle associated with conservation practice adoption or conservation adoption for a 2-year program versus a hassle for a 10-year program. Okay, it's worth the hassle for a 10-year program, but at 2 years, maybe it's not worth the hassle. Another finding that comes out is local demonstration and how important it is for farmers to really see with their own eyes in their own neighborhood the practices actually working. So one of the recommendations that's come out is that we develop more larger scale demonstration practices across more of the landscape. So here's one. One of the comments I hear is they don't trust test plots. It's just not not a big enough data sample. It's like probably true for that little speck, but what about the whole farm? So having a bigger sample. Or it's got to be from a farmer in our area. It doesn't matter to me if it comes from Purdue or Illinois or anywhere. It's got to come from someone in this area on these soil types. What matters is the people in this area that have grown it on 80 acres and average that yield. Then we'll go for it. This improve outreach to non-operator landowners and farm managers. So this goes back to that rented land question that we've discussed a couple times in this presentation. The innovative outreach to both the landlords and also the farm managers who are intermediaries between tenants and their landlords. The landowners would have to at least understand, same as the farmer, that there's a value in conservation. Same message that you got to convince me that the cover crop has a value and it affects my bottom line. This has a value. If you convince them that they're protecting their long-term investment, then there's maybe even more of a value to them than even I have on a year-to-year lease, where I'm just struggling to make my tractor payment or combine or whatever. Farm managers, they have to encourage it with the landowners. And then, of course, then they can pick and choose who they want to farm on the ground because of that. Farm managers manage a lot of this rented ground. Not all, but a lot of it. Their bottom line is affected by 12% or 10% or whatever the gross. And if they aren't getting very much gross, they don't get very much return. So again, they have to educate the landowner. And so this is really critically important, particularly in those areas of the upper Midwest that, more than half, almost 2/3 or 3/4 of the land is rented. We really have to come up with some solutions to developing more effective partnerships, conservation partnerships between farmers and landowners and farm managers. Now we have a couple of other important considerations. I think I said at the outset that something along the lines of the need to document or put a value on the the nutrient loss abatement. And one of the things that comes up over and over in interviews and focus groups is that research-based information on fertility and soil health and yield impacts of these different practices is critical. Farmers really want to know, what does the soil health mean now in the short term, but especially in the long term? And can we put a value on that then could be reflected in, say land values and, the yields. And then market segmentation. I think one of the things that's coming out is that, that we're increasingly realizing is that farmers are a very diverse group, and what's the message that's right for one farmer might not be right for another farmer. And so we're doing some interesting research in developing typologies of farmers. Are there more conservation oriented farmers, more productivist oriented farmers, and then trying to tailor messaging and communication strategies for each group. And so in closing, I just want to say kind of a final note on soil health. If we look at all the research that's out there, particularly the qualitative research and also just the interactions that we're having with farmers at field days and so forth, the concept of soil health really is resonating with farmers in the US, in particular the upper Midwest. Of course, I'm most familiar with that area. But one of the really important things about this is that soil health is kind of an integrative concept that helps farmers think holistically. So, you know, in order to get soil health, you have to do a lot of, you know, to get healthy soils, you have to do a lot of different things, multiple practices that complement each other, and think about your farm in from more of a systems thinking approach. And so it can be, you know, once farmers start thinking about soil health, it seems like they start to think more holistically. And when they think more holistically, they tend to start thinking more long term. And I think, you know, you all know that, you know, commodity production is a really, in most years, is really tough, right? Because, you know, you got farmers thinking on 1 year, 2 year, at maximum kind of 3 year production cycles, and they're not sure, you know, given commodity prices, if they're going to be able to make their profit margins. So, you know, I've heard so many times from farmers that they say things like, if I'm not sustainable in the short term, I'm not going to be sustainable in the long term, which is kind of shorthand for I'm cutting corners. But thinking about soil health, I think, helps to bridge that kind of short-term and long-term thinking, because the primary benefits of soil health are accruing to them and the next generations of farmers on their land. And really critically, and I think Tom said something at the outset about this, is that the practices that lead to healthy soils, even though the, you know, no-till cover crops and so forth are, you know, the benefits of healthy soils accrue to the farmer, and the farmer understands it that way, they also lead to major on and off-farm societal benefits, such as soil building, water quality, carbon sequestration, etc. So your classic win-win. So I just want to acknowledge my colleagues. They're all over the place: Purdue, Montana, Bates College, a number of different universities around. Let's see, the group I'd say is led by Linda Prokopi and Kristen Flores and myself. And we call ourselves Team Ag Bmp. We've been working together for a number of years, and we were the group that worked on those 2 papers that produced the results that I shared with you today. So I just want to acknowledge that group. And I want to let you know that this presentation is available. All the references that were, you know, that I referenced in the presentation are listed here. So if you want to grab the presentation and get into the more details in those studies, I welcome you to do it. They're really good studies. And that's it. Thank you very much. I really appreciate having had the opportunity to dump all that information on you.
Thanks, Jay, so much. It's Ellen here again, and there are some 6 questions or 7 questions already in the Q&A, which I'll read out to you shortly. One's been voted up with 7 votes so far, but a reminder to people that they can put their questions into the Q&A and also have a look to vote things up. Thank you so much for these really wonderful insights too on these different barriers and what can help facilitate that. So I'll start. But right away, I'll start with a question. The first question comes from Anne Verhalen. I find the observation about systems thinking interesting. Most of our innovative and early adopter producers can be generalized as system thinkers. How can we use this information to reach those who don't operate that way? How can you craft message and information to non-system thinkers and to ensure success?
Yeah, well, so we've had this discussion with my colleagues, because it does seem like a lot of the farmers who are really doing the, you know, bleeding edge, you know, cover crops with no-till, with you know, extended rotations and other stuff are viewed in their neighborhoods as mad scientists, perhaps would be a nice way of saying it. And so, you know, they're not necessarily the kind of the thought leaders or opinion leaders. They're definitely doing really interesting, out there, cool stuff. But you know, the kinds of things they're doing may or may not resonate with some of their more conservative neighbors. So I think this is a really, really important question. I think one of the things that would help, and we've been having discussions about this in Iowa, is bringing the crop advisors on board more as partners in this, because, you know, I think crop advisors are the folks that farmers trust the most, and crop advisors are increasingly, thinking about soil health and understanding that soil health resonates with farmers. And so, the more that we can get them on board, because quite frankly, farmers and their trusted crop advisors are making decisions together, right? And so helping both of them feel more comfortable and helping both of them think in terms of systems together, I think could be a really, we're thinking could be a really strong facilitating factor.
Thanks. And your next question is also being voted up. You mentioned that you were working on tailoring messages for different groups of farmers. The Ontario soil, where did that question go? It got moved.
I see it. So
okay.
Soil health strategy points to this as a necessary piece for moving forward with soil health messages. Can you share any of your early observations? So actually, I and two colleagues just last week published a paper in Land Use Policy, the journal Land Use Policy, and it's open access. So I guess I could find a link to that and share it with you all. So we just developed a typology of Iowa farmers, and based on, so I run an annual survey called the Iowa Farm and Rural Life Poll. We survey the same farmers year after year. And so we took 3 years of the survey and 109 different variables, many of them related in some way to conservation practice use, and used cluster analysis to develop a typology of farmers. And we found 4 types of farmers. One we labeled conservationist, one we labeled productivist, one we labeled deliberative, and one we labeled traditionalist. So I can't really get into the details of this, but what we, just kind of the basic findings are that I'll take the deliberative. So the reason we call them deliberative is because they seem to be conservation oriented, but they have the highest perceived risks. So they perceive the benefits of conservation practices, but they're also the most worried about perceived risks. And they tend to be very trusting of most sources of information. And so that, I think, really provides evidence toward, I talked in the end of my presentation about the importance of focusing on risks and perceived risks. Like we tend to talk a lot about barriers. And so the information we have about this deliberative group kind of suggests that it would behoove us to focus on helping farmers to better manage risk, or know how to better manage risk, because that then can move them into a space where they feel that stronger perceived capacity or self-efficacy to adopt the practices. And so, I mean, that's kind of some initial conclusions coming from the typology work. I would be happy to share that with you. And I'm also, what we're doing is a second round of research. Most of the variables that went into that typology development were like unobserved variables, like attitudes, values, and that sort of thing. And so now the next step is to take a look at observed characteristics like size of the farm, the mix of crops and livestock, whether or not they have different other aspects of their farm, to see if there are ways to differentiate these groups based on observed characteristics, where we could say, oh, this group is like smaller scale, more diversified. This group is larger scale, more specialized. So yeah, that's a long way to go.
I think that'd be great to have that paper too, that you mentioned. Thanks. We get that reference from you. Okay. Here's a question from the Maffer Fields crop team. Any insights on the general relative weight of different barriers and facilitators? Some of these are much more easier to act on than others. Would it be enough for extension specialists to address, perceive the risk and benefit? Like, how do they pick which ones?
Yeah, so that's a really good question. And one thing I didn't mention about the extant research is that, even though these fairly consistent, the predictors that we find and barriers that we find are more consistent than others, are not as consistent as we'd like them to be. So there's a lot of uncertainty in there. But gosh, it's hard to say if there's more weight to some than others. Wow. I'd say, focusing on the well, focusing on communicating the benefit to the farmer, and that's huge, right? So that's one of the things about soil health that I feel is one of the strongest sells, is that for so many years we talked about soil and water conservation practices as, you know, the reason we should do them is because it's going to help out our folks downstream. It's, you know, it's going to lead to better water quality. We're not going to be, you know, adding sediment to the waters. The beauty of soil health is that it's a benefit that's accruing to the farmer. So the degree to which you can talk about the benefits of that, but also, I mean, I really feel like helping to manage the risks of, like, if I were to choose one, I'd say, number one, talk about soil health, and then talk about, you know, managing the perceived risks associated with the soil health practices, like cover crops and no-till, because that's time and again, that's what the farmers say. You know, I would do it, but, you know, the risk to yield. Oh, but, you know. But I also think that it needs to be a really, you know, holistic approach to, you know, dealing with the barriers and, you know, promoting the facilitators. So I don't think that there's, you know, necessarily any low hanging fruit, except for maybe the perceived risks.
Thanks so much. And the next question comes from Ruth Knight, who've been voted up. Have you reviewed the impact on non-farmers' interests in soil health on farmers' decision making?
Well, so that's a great question. And so, you know, through the, you know, we know something about, you know, the farmer, about the landlords through their farmers. There's a recent study that was sponsored by the American Farmland Trust that is kind of they did a survey of non-operator landowners across the U.S., I think 10 states across the U.S. And what they're finding, and this is something that we found in Iowa as well, is that non-operator landowners, the landlords, I think that Ruth was referring to, they actually have greater, you know, higher levels of environmental concern than the farmers do. But what I think is happening is that their levels, I mean, they often tend to live in cities far away from the land. So while they might be kind of environmentally aware and, you know, concerned and have strong environmental ethics, they may not necessarily know what's going on on their particular land, and they tend to trust their tenant farmer, who may be, you know, a niece or a nephew or a cousin or an uncle or something like that. And it's very difficult to have those conversations. So I think that is something that's critically important. I don't know how it is up there in Ontario, but I imagine it's somewhat similar. You know, how can we develop those partnerships, conservation partnerships between landlords and the farmers who rent from them? It's a hard conversation to have from a landlord's perspective, because if they ask, you know, bring up cover crops, for example, they're afraid that the tenant might get offended and, you know, think that the landlord doesn't have much confidence in what they're, you know, in what they're doing. And likewise, you hear this time and again from the tenants, is they're like, well, I'd love to do cover crops, but I don't know that my landowner would pay for them. And they'll give examples. They'll say, well, I brought it up with my landlord. I would talk to them about cover crops, and they said, well, that's a great idea, that you should do that. But they didn't offer to lower the rent or otherwise help to facilitate that. So there's kind of dynamics on both sides there. But I think, you know, those dynamics really provide evidence that we need to develop partnerships. One thing I'd also say on that is it's really hard to contact non-operator landowners. I don't know, at least here in the upper Midwest, you know, we have lists of farmers, but we don't have lists of non-operator landowners, just the tax rolls. And you can look at tax rolls and you don't know whether they're farmers or non-operators unless they live out of state. But oftentimes, yeah, it's a very tedious process to try to develop a good list of non-operator landowners.
Yeah, so another barrier to find out that information. Yeah,
exactly.
I think we
and
have
to contact
time.
them.
Yeah, I think we have time for one last question. This one's from Paul Smith, who is a former OMAFRA, now on to different retirement and new activities, and he was involved in developing soil strategy. His question relates to later adopters may perceive higher risks of adoption of soil health practices. What can be done to reduce the perception of risk as opposed to the actual risk? Insurance on yield, if reduced due to PMB and BMP adoption, best management practice adoption.
Mhm. Yeah. Well, so that insurance, I think, or any kind of like cost share that goes over multiple years, I think is one of the, I think I mentioned in my presentation that developing maybe more, longer term cost share or some way of helping to bring the farmer through those critical first few years, but also demonstration. I think it really, you hear it time and again, farmers saying, if I don't see it happen in my neighborhood, then I don't know that I would believe that it can work here. And so you have all kinds of cool research going on your university research farms, but it's small plots and it's not necessarily in the neighborhood where the farmers are. So farmers want to see it happen in real world situations, and which is why like field days where real farmers are showing off what they're doing are so important. We have a group here in Iowa called Practical Farmers of Iowa, which does a really wonderful job of conducting research trials on actual farms. And so they work with farmers members to establish trials that are large enough that, when farmers see them, they're like, okay, yeah, I can see that, the results there. And then they bring farmers to those farms. And so it's farmers talking to farmers about their experiences. And they're always, they're brutally honest. They'll be like, I really messed this up. This is a mess. I'm embarrassed to bring you here to see it, but it's important for you to see it because this is what I did and this was what I would do if I had to do it again. Yeah, so demonstration trials, particularly if it's farmer to farmer, but local is really critical. So those kind of conservation oriented social networks, whether it's farmer to farmer or farmer researcher and crop advisor, I think we just really need to build capacity within those networks where everybody's feeling more confident, and I think that then reduces the perceived risk for everybody, hopefully.
Yeah, thank you so much. Is there we're sort of wrapping up our time for any questions, so because we have a bit of a break and then we'll have to start our second session, but is there some final remarks that you'd like to share with us, final wisdom and insights? And I do appreciate all the resources you provided us, and we'll have the PowerPoint, but any words that you'd like us to
Well, I guess I'd just say, well, first off, I just want to thank you for having me. And I really appreciate the focus on social science research. I really feel like we're beginning to, appreciate the social science research more. 10 years ago, it wasn't so much. And I would also say that, social science research is really difficult because, people are slippery and they, so, it's hard to predict behavior. I often say, when my biophysical scientist friends talk about, social science is like a soft science or not a hard science, I say, wait a second. No, I think that social science is the hardest science because people are just impossible to decipher. But I'd say that we should continue to develop partnerships between social scientists and biophysical scientists, and then agricultural stakeholders across the realm, because the problems that we are facing, whether it's nutrient loss or soil erosion, soil degradation, greenhouse gas emissions, climate change adaptation and mitigation, it's going to take all of us together to resolve them. And I think the most powerful projects are what we call down here, and you probably do up there, transdisciplinary projects, where we have researchers from all different disciplines and agricultural stakeholder practitioners working together on those problems. So I'd say that would be my, that's my hope for the world, is that we'll develop more of these large scale networks, transdisciplinary networks, to deal with these really difficult problems that we face.
Thank you so much for those words of wisdom and those insights that you've shared with us today. I really, really appreciate you taking the time to be a part of our event. Thank you so much. And I wish we could all give you a hand clap and say thank you. But I'm sure the group of 212 people are thanking you as well.
Yes.
And so we'll share all your resources that you shared with us with people, and we are recording this recording. So thanks again once more.
Thank you. It was really a lot of fun.
Great.
I'd be happy to come back in the future.
Great. So now we have time for a 5-minute break. This has been designed so that we can keep having a good afternoon together without getting zoomed out. So please turn off your, oh no, don't turn off your Zoom, but hang tight, come back in at 2:05, and we'll start with our next presentation, where we'll be learning more about the behavioral insights and adoption from the Ontario scenarios from some funded research from OMAFRA and the Alliance. Thank you so much for your questions you've asked. Jay, those were very insightful. I wish we could have had time for more. Take care. And so join us back again at 2:05. Thanks very much, everybody. Hello all. So we're ready to get started again. Thank you so much for showing for having a little bit of a break. Hopefully that was enough to grab a coffee or do whatever else you need to do, but I'm inviting you back into the room, as it were. Now come back from your coffee break. And we're ready to get started on our next session. This session, as I mentioned before the break, is about all about Ontario soil understanding behavior change from two researchers in Ontario, from Erin Nilsson and Richard Vine. And then the second half will be a bit getting some insights on some baseline understandings of soil. So getting more into the scientific depth of biology and physics and chemistry of soil. So right now I'd like to invite my colleague Erin Nilsson to turn on her video and her microphone. I see there was a poll. You guys have already decided what type of bug soil organism you are. So we seem to have a lot of earthworms and also some fungi. I don't know if that's a good thing or a bad thing. So Erin Nilsson is presenting first, and then Richard will join in after. Remember to ask your Q&A in the Q&A button, not the chat. And so Erin Nilsson, thank you for joining us. And she's an assistant professor in the Department of Sociology and Anthropology at the University of Guelph. So without further ado, over to you.
Thanks, Ellen. And I'm just going to try to share my screen and hopefully this works.
It's looking good. Once you put it in presenter mode, it'll be perfect. There you go.
I'm working with two screens for the first time ever in one of these Zoom calls. So hopefully it all goes smoothly. Thanks so much for the invitation to present today. And I appreciate the little survey questions. It sort of helps to make me feel a little bit like I'm in the same room with people, although I'm actually just speaking to my computer screen. So my research that I'm talking about today is a project called Social Networks for Healthy Soils. And it was kind of nice to hear Dr. Arbuckle, in his response to Paul's question, mention the importance of these kinds of peer farmer-to-farmer networks and also farmer researchers, because that's really at the heart of this project. So a nice kind of segue into what I'm going to talk about. I just want to acknowledge my co-authors on the presentation, Yasser Arafat, Dr. Sarah Hargreaves of the EFAO, Alexander English, also of the EFAO, Tori Waugh of the Ontario Soil Network, and we've also been working with Andrea Dubé-Goss of the Ontario Soil and Crop Improvement Association, but she's in a transitioning period, so wasn't actually able to contribute to today's presentation. So the work that I'm talking about today is part of a participatory action research project. And I should mention that my background is not in soil health. My background is more in community development, but I have a long-standing relationship with the Ecological Farmers Association of Ontario, and I've worked with them on a variety of projects over the years. And the impetus for this project really came in conversations with them and also with the Ontario Soil Network about how important soil health is in the underpinning for our agricultural system and also for our communities. I mean, it's obviously important for farmers, but also, as Ellen mentioned at the outset of today, for eaters as well. And in talking with EFAO and the Soil Network, and then later on also with OFCIA, it became really clear that participation in farmer-led social networks and peer learning programs is fairly correlated to soil health BMP adoption. But these organizations were saying, like, we understand that this is the case, that our farmer-to-farmer programs are supporting farmers in uptaking soil health BMPs, but we could use a little bit more information, systematic information about why that's the case and also how those processes are functioning. And that really resonated in the literature, where we were looking at a lot of studies that were suggesting similar things, that being a participant in a social network or farmer-to-farmer program did seem to be positively correlated to adopting soil health BMPs, but there wasn't really so much in-depth understanding of that kind of nitty-gritty of how and why those processes were working. So with that in mind, the objectives of our research are to evaluate the impacts of 3 specific peer learning programs in Ontario run by those 3 partner organizations. So we're looking at the EFAO's Farmer-Led Research Program, the Tier 2 projects run by Soil and Crop, and also at the Soil Network and its kind of holistic suite of programming, which essentially functions as a peer-to-peer learning network. In addition to evaluating those programs, we're also looking at peer learning best practices. We're analyzing factors that support or constrain the success of these programs. And the big picture goal is to develop a set of recommendations for how OMAFRA and also potentially other institutions can better support these programs and help them expand the scope of their impact. We're in really early days. Well, we're just past the year 1 mark, but as everyone on this call I'm sure is aware, it hasn't been for many of us the most efficient year of our lives. So we're a little bit behind where we had hoped to be at this point in terms of collecting and also analyzing the data. That said, I'm going to speak to some preliminary findings that we have today. The first is that one of the first things that we sought to do with this project was help the 3 different partner organizations develop logic models for their specific peer learning programs. And that meant really helping them think through what their program activities were and how those activities related to short, medium, and long-term goals. And we worked with each individual organization, but then we also brought the 3 organizations together to identify some common themes across those program logic flows. And I've just got them up here. There were 5 key themes that really each of the programs was trying to achieve. And the first foundational element was growing and changing farmers' social networks. And I'll speak a little bit more to that later. Improving knowledge regarding best management practices, increasing confidence and motivation to use the BMPs, enhancing farmer capacity to use BMPs, and then of course, increasing that adoption. And then underlying or sort of cross-cutting across each of those specific program objectives was this idea that at their core, really these programs were about facilitating farmers' ability to shift their perception of risk, which has been talked about a lot today, and also their perception of trust. So what information sources are they trusting when it comes to making decisions about on-farm management with respect to soil health? So we used those logic models and the collaborative logic model to develop an online survey to as sort of the first step of the research. And the survey was meant to help sort of assess program success in terms of meeting those impacts. And we surveyed EFAO, OSCIA, and as the Soil Network member farmers, focusing on the peer learning program impacts. We had a total of 291 responses, and you can see the specific numbers across the organizations there. And we're just, like I said, in the really preliminary stages of analyzing this data. So the findings I'm going to speak to, there's a lot more number crunching to be done. But one thing to put up is just a quick snapshot of what farmers said the impacts were in terms of increased knowledge, motivation, confidence, being introduced to new innovations, and then being supported in improving and adopting soil health BMPs. And you can see that the numbers are fairly high across those impact categories. Soil and Crop Improvement Association numbers are lower, but what was interesting to note there was that a lot of the people who actually completed the survey weren't familiar with the Tier 2 on-farm research program, so that is part of the reason for that discrepancy. So we still need to crunch the numbers a little bit and see of the people who had a deep understanding of that program, what their responses were like. But generally speaking, I think this demonstrates fairly solid impacts across those desired categories. Another notable finding, just again, like I said, from the preliminary survey data analysis, is farmers were asked about the main barriers to adopting the BMPs. And interestingly, the biggest barrier that was cited by these farmers was a lack of materials. That was the most commonly cited across the 3 organizations. And that was something that farmers were asked about in terms of program impact as well, was were the programs supporting them and actually accessing the resources they needed to adopt BMPs. And it's interesting, this was one of the biggest barriers, and it was also one of the places where farmers didn't note a particularly strong program impact. So that's something to dig a little bit deeper into. And really, one of the main areas that we want to dig more deeply into with the in-depth interviews, which are happening now, they're ongoing, we're doing a set of follow-up interviews, is this importance of relationships and how participation in these programs is helping shift farmers' social networks in a variety of ways. And like I said, my background is in community development and rural sociology, and we talk a lot about social capital, and specifically different types of social capital. So whether it's relationships between people who are different or people who are the same. And it was interesting hearing Dr. Arbuckle mention the one farmer's mother being kind of an impediment to adopting BMPs. And one of the things that these programs are doing in many cases is expanding farmers' social networks beyond just their maybe immediate family or immediate neighbors. And these quotes here demonstrate a few of the different ways that farmer relationships are helping to shift people's ideas about BMPs and also their adoption of BMPs. So you can see it's contributing to farmers feeling inspired, to feeling more committed. Seeing different approaches actually leads to help in implementing them. And I think this last quote is interesting, this idea of being brave enough to try cover crops and the ways in which a particular constellation of social network can actually help people feel a little bit braver. So like I said, these are kind of tricky, complex things to be looking at, and the survey gave us really broad strokes idea of what's going on. But what we're doing now is these in-depth interviews with the survey participants. We're also doing a best practice review, and longer term, we want to also do some interviews with farmers who aren't part of these peer learning programs to help us gain a broader understanding of what some of the barriers are.
Thanks so much, Erin. I know these are just quick snapshots on your research. I really appreciate that. If anyone has any Q&As, put them in the Q&A. Any questions, put them in the Q&A area, and we're going to move on to Richard Vine. If you want to unmute yourself and put your video on and start sharing your presentation, that would be just super. And I hear a lot about relationships being important, and trust, and neighbors and influencers. Richard, over to you. I know you've got some research that you've been working on, some fresh hot off the press.
Yeah, thanks, Ellen. Yeah, I'm just going to share my screen here. Hopefully you can.
I can see it. Yes.
Yeah. Okay. So what I'm going to talk about. Yes.
No, all good. Go for it.
Yeah, I'm going to talk a little bit about the survey that I conducted, and about why people adopt or don't adopt different soil health BMPs. So as a bit of background, I am an economist, so hopefully that statement doesn't completely discredit everything I have to say here today. But on the other hand, I did grow up on a farm, so I do have some knowledge about how things work in the real world. So last winter, this is a project funded by OMAFRA. I conducted a survey of producers just to try and find out more about what's going on in terms of their adoption decision. Now, there's been a fair bit of work that's been done in different jurisdictions, particularly in the US, but we kind of wanted to get some information that was Ontario specific. So we looked at asking about 6 different best management practices, which are listed here. So the cover crops, crop rotations, reduced tillage, soil testing, windbreaks or buffer strips, and organic amendments. Now the response rate, of course, we always want more, but it was decent. So 249 responses, which can help just to get some type of idea about who's using different practices, and for those who aren't and why they're not using them, what might help them start using them. So this slide just kind of summarizes some of the results for each of the 6 practices. So you can see how many are using them. A couple things to note here. The numbers don't all add up to 249 because in some cases the practice didn't apply to a specific farmer situation. So they would have replied as such. For the soil testing, that refers to people who have conducted soil testing at least once every 3 years, and some would be more frequent. For the organic amendments, that refers to people who use organic amendments every single year. Now you can see, for example, with cover crops, the proportion of respondents that use cover crops seems to be quite a bit higher than, the number that, based on, I think, Stats Canada's information, we have a fairly low proportion of farmers that are using cover crops. So you may argue, well, this survey is probably not, probably doesn't give you a good snapshot of, who's using it. Maybe it's not a proportional response, but in a sense, that doesn't entirely matter. I mean, as an economist, let's focus on what useful things there might be in this data. And really, this project was conducted not to get necessarily a proportional sample, but to identify those that use a practice, find out why they use them, and then get a sample of producers that are not using it and find out why they're not. So the distribution of the sample between the two, in a sense, may not matter as much. So then I conducted an analysis to see which factors may influence the adoption of each of these practices. And you can see here where there's statistically significant results I indicated with either a positive or a negative impact. So you can see farm size doesn't seem to have much of an impact on whether farmers are adopting any of these practices, but whether you're a full-time farmer does have an impact. Whether you're have post-secondary education, that seems to have a bit of a positive impact. But you can see there's not really a consistent result across all practices, which may be expected. When you look at some of the work that's been done, which Dr. Arbuckle referred to earlier, some of the research on the factors that may influence adoption, the results are kind of all over the map. In some cases, certain characteristics do have an impact, and in other cases they don't. So that's kind of why I wanted to do this research here for Ontario farmers, to kind of see what the results might be here. And so you can see there's certain factors that do play into whether a practice is adopted or not. What we were a little more interested in is to find out, well, if you're not using it, why not? And what I've done here in the next 3 slides is list the top 3 reasons that were provided as to why farmers would not be adopting each practice. So for cover crops, it's the additional cost or lack of return. That was the most commonly cited reason. It's also the management complexity, the fact that you need additional machinery for some of them, and the additional time. For crop rotations, and sorry, just one note here, when we talk about crop rotations, if you're using crop rotations, that's using rotations that have more than 2 crops in it. So you're getting away from just the corn soybeans rotation. Here, if you don't have the equipment for other crops, if you don't grow annual crops, or there's a concern about lower profits that are associated with other crops. With no-till agriculture, the concern about the cost of the equipment, there may be delays in planting, you may have to increase herbicide use. So those are the top 3 concerns that were expressed there. For soil testing, there's the cost of the testing, the uncertainty about benefits from doing more frequent soil testing, and then the time requirements to actually go about doing the testing. For windbreaks and buffer strips, in many cases there just wasn't unprofitable or fragile land on the farm that they figured would need to be converted into something like a windbreak or a buffer strip. There's also concerns about reducing profits because you need to take some of this land out of production, or again, in some cases, there's just not a concern about soil erosion on the farm. And finally, for organic amendments, there's a concern related to uncertainty about the benefits of using them, or about what's in them, how that may affect their land, and also about the cost. So for those that have not adopted these practices, also wanted to try and identify, well, what would encourage you to adopt these practices? And so, as you can imagine, one of the top item identified as something that may contribute to future adoption of the practice is financial incentives. And if a farmer did indicate that this would increase their adoption, then they were also asked, well, what proportion, what percentage of the cost should the cost share program provide? And there, by far, the most frequent response was 50%. There's also, another factor that would contribute to increased adoption would be better evidence of economic benefits. That's a concern. I mean, yes, it's generally well known what the environmental benefits are associated with some of these practices, but what's it going to do for my bottom line? And then the education aspect. In some cases, there's just not enough knowledge about how exactly to implement these practices. So just to summarize, essentially the biggest barrier to adoption identified by participants in the survey is related to costs or lower profits. So it's that financial aspect. The factor then, accordingly, the factor that's most likely to increase adoption would be financial assistance. But it's important to note that it's not just about the money. There's other concerns that were identified. Yes, financial assistance may help, but you don't just want to focus on that aspect of it. There's also needs on the education component of it. So trying to provide additional information there may be helpful, and just better evidence of what the benefits may be. There's one quote that I've added here at the end that in response to the cover crop example. So why aren't you using cover crops? And the answer here is there's too much experimentation going on right now. I want a specific and proven action plan for my soil types that will improve soil health, yields, and economic returns. So, I mean, that's good news for us researchers. We need more research done. But on the other hand, it's also a bit of the impediment right now because we don't have good enough evidence to convince enough people to use them. So I thought that was an applicable quote there. So that's just a brief summary of the results. And yeah, I'd like to stop there and open it up to questions.
Thanks so much, Richard. And Aaron, if you want to come on screen as well, that was really good. Maybe Richard, if you could stop sharing your screen, that would help. And we have a question right up. Yep, sure. Just have to stop at the bottom sharing your screen. There we are. And Aaron, I see you there too. So the question is for you, Dr. Vine. How would you address the environmental goods and services in your research and approach to adoption, given that biodiversity is overlooked in much of the production economics, yet it is much in peril as ecosystem function?
Yeah, that's tough. I mean, it's important to consider that because it's a benefit that goes well beyond the farm. And when you think about what goes into producers' decision making, that's they're going to be a little more focused on the economic impacts on their own bottom line. But it's there's all these other benefits that go beyond any potential financial benefits that kind of benefit everybody. So how would I address it? Well, I have done some research on cover crops, and we tried to look at and tried to account for the potential value associated with the ecosystem services, and really, to have that component influence the decision that's made on the farm. I mean, that's essentially that has to happen through some type of program that would provide financial assistance. So I'm just taking a look at the question, make sure I'm answering it. Yeah, it is. Biodiversity is overlooked in part because it's too hard. As economists, how do we account for something for which there's no there's no market for it, right? How do you determine the value to society? So it's easier to focus on the potential benefits or the costs at the farm level because there's better information. So it's very difficult, but I think it's important to include because it's it's part of this whole part of the practice and part of the benefits that result from using them.
Thanks so much. I'm sort of curious to know also, what are you hoping to find, like the outcome of your research? And this is a question for both of you. Like, really, what are you like? Because what I heard from Jay was that there's no one way easy to do this. We can't, there's lots of different bits and of farmers understanding them and practices. It's like, so what are you hoping to add to this understanding, I guess? And Erin, to start with you.
Yeah, I think definitely, you know, there's been such a wide variety of factors talked about already so far today. And what we decided to do in our project was to some extent narrow in on these peer learning programs and say, okay, they're obviously not a silver bullet, but they're one piece of the puzzle. And they've been fairly widely identified as a pretty common factor that's positively correlated to adoption. So how can we just kind of narrow in on that piece and understand it better? And I think, you know, there was a lot of anecdotal evidence on the part of the partner organizations we're working with in this project to say, we know these programs are working in some respect, but A, we don't know exactly how they're working. We don't have a good sense of our impacts in a systematic way. And B, we don't have a sense of how to expand the scope of our impact. So we want to better understand our impact and figure out how we can broaden it out beyond just sort of the usual suspects who are going to just naturally be attracted to our organizations. So that, I would say, is the big thing we're hoping to get at through this project.
Great, thank you. Richard, what would you like to, what are you hoping that will know by the end of your project? A bit
I guess what
to share.
Yeah, what I was hoping to find out is just a little bit more about, you know, why farmers aren't using them and what would encourage them to adopt. I mean, and sometimes that's a little bit tricky to get just from a survey. You know, it helps to also drill down and do some more qualitative research, but at least it's a start just to find out, you know, what are some of the biggest concerns, you know, what are the biggest barriers. So I think this was intended sort of as a starting place for trying to learn more about what's going on the farm in terms of why these practices aren't being used.
Great, thank you. So we have time just for one more question, I'm afraid, because with these virtual events, and we wanted to get a lot of researchers speaking, and sharing results, giving research updates. So we have a question here from the OMAFRA field crop team. How can we factor in long-term benefits in economic analysis? What method can we use to the value of the benefit of soil health improvements? How much money is lower bulk density worth higher infiltration rates? I'm assuming that's for the economist.
Yeah, it's tricky trying to attach an economic value to an environmental benefit. I think it is possible. Like, you know, I referred earlier to the research on cover crops, and that was from Dr. Laura Vinaird's experiment at Ridgetown campus, where there's a kind of a longer term experiment going on, and it allows for collecting data that, you know, where you can see not just what's happening, you know, in 1 year from using different practices, but you can also measure changes in some of these environmental factors over time as well, and, you know, hopefully use that. I mean, it always comes down to data and having the right data. You know, once we, you know, for example, for this experiment, some information on carbon levels in the soil was collected. So that allows you to compare carbon levels for plots where you aren't using cover crops versus plots where you are. And then you can start with that data and then try and attach an economic value to the additional carbon in the soil. So that's sort of the starting place, but yeah, as an economist, we always like to see more data.
Great, thanks so much. I have a question. I have a question for Erin here. Erin, have you noticed differences in benefits of farmer to farmer peer group based on format, online, in person? Have you noticed?
Yeah, it's an interesting question. It is something that we looked at. The respondents talked about what ways in which they were engaging with the different peer learning programs. And like I said, we haven't crunched all the numbers and divided that out, but definitely if we look at the open-ended questions in the survey, the thing that gets talked about most is the actual on-farm visits and field days. So there's definitely a sense that those are having a really particularly strong impact. That said, a lot of people did mention just taking in results of some of the farmer-led research and on-farm studies by reading a newsletter or hearing about them at a conference. So yeah, I don't have a quantitative answer to that question, but it's definitely something that we're looking into, and we did separate that out in the survey, so we'll be able to get a better sense.
Thanks so much, both of you, for your presentations and for doing this. I know these are just speed dating type, quick, speedy presentations, but I did want to let the audience know that there is a resource website where we're going to be posting this presentation, and opportunity to, the questions will be shared with the researchers afterwards. And there's also some recording on the on-farm program, which talks about more what they refer to as local, more ways that people can see demonstration about soil health. So I want to thank you too, Richard and Aaron, for your research you're doing. It's really important research, and for sharing your research findings today. And I really much appreciate it. So hands over, clap. You guys, thank you so much. And so I'll ask our colleagues, our next speakers, because we're just go, 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 is Dan Surratt from OMAFRA, and Carrie, I think you're coming on at the same time, or maybe you'll turn your screen on afterwards. Just a reminder to put your questions in the Q&A section of the tab, and then if you write them in the chat, we have a hard time capturing them in the Q&A section. So I'm looking for Dan to turn on his video. Have I got Dan somewhere here, and to start sharing your presentation as I do some welcoming remarks?
Yep, I will post it in 1 second here.
Oh, great. Hi, welcome to Dan and Carrie, who are going to do the next session. And this is section 2.2, which will highlight topsoil inventory research, looking at soil management practices, influences, and collaborative biological research. Dan will be presenting first, and then Carrie Dunfield will join. Remember to put your questions in the Q&A as tab. We'll answer all the questions after Carrie speaks. Daniel is a land resource specialist here at OMAFRA, and Carrie Dunfield is a professor and Canadian Research Chair of Environmental Microbiology at the University of Guelph. And so we welcome both of you to speak to this topic, topsoil sampling program. Okay, over to you, Dan.
Thanks, Ellen. Yeah, so Carrie and I have the pleasure of being able to introduce you to some of the initial results from the topsoil sampling program. And so I'm going to just jump right in. I think a lot of people have heard about the program. However, it's a collaborative project that we've set up with the University of Guelph, which we launched in 2019. We identified a need for baseline data on soil properties and soil health across Ontario. And so really we're collecting data in kind of 3 key areas with this program. We've got a land management survey that we do with our collaborators. Soil and landscape data is being collected when we're out in the field, and we're collecting samples and getting analytical results from the lab, which we'll touch on shortly. In terms of site selection and sampling status thus far in the program, so we've used a very specific site selection algorithm which focuses on sampling from a number of different environmental data sets to try to best represent those data sets across the agricultural landscapes of Ontario. So you can see there a list of different what we call covariates that we used to do the sample selection. And I just wanted to highlight that 2020 was supposed to be our second kind of full summer of sampling, but because of COVID, we're behind by a year. So we're done about half of the sites, and we hope that 2021 will be spending more time in the field to finish up the sampling. In terms of sampling methods, so what are we doing? So property access is granted by the landowners, of course. We complete a land management survey with those landowners at that time. We don't really contact the landowners ahead of time. We kind of knock on the door, introduce ourselves, and so far we've been received fairly well. At each site, we do 3 different soil pits. We're really focusing on the topsoil layer for this program, and we're sampling from different landscape positions, upper, mid, and lower landscape positions. We collect soil samples. We're also collecting bulk density information, so taking soil cores. So I'm going to focus on this. You'll see the rest of this slide later in Carrie's presentation, but essentially I'm going to focus on OMAFRA as part of this program, where we're looking at kind of some baseline chemical and physical data associated with the soil samples that we've collected. And this may be a bit of a carrot dangle for the producers, probably not so much, but we like it. We've come up with a way to do some fairly easy customized reports for the landowners where we can provide them with some maps of the sample locations overlaid on top of their field, and then we provide them with some of the results from the analytical work that we've been doing so far with chemical and physical parameters. And there's potential to follow up later on, hopefully with some of the soil health test results as well for those that wanted results. So to jump in quickly, we've got a series of 15 questions for the landowners. They're fairly high level and generic, but we just want a basic understanding of their management practices. So here's a couple of examples. We want to know, are your crops in rotation? Yes or no. You can see here 80% of respondents are saying yes to a crop rotation, and we would define crop rotation as anything more than a single crop. We also ask questions about cover crops. So are they using cover crops, yes or no? You can see our numbers are slightly higher again than the census data from 2016. And again, in the last presentation, we saw that those numbers are even higher. So there's obviously some variability in some of these results. We're interested in the type and use of organic amendments because we understand that those can help build organic matter content in the soil. So you can see here about 50% of respondents not using any type of amendments, and dominantly on the yes side, it's manure. And we also have a breakdown of the types of manure that are being used. We also wanted to look at some of the results in terms of the relationship to whether a field is owned or rented. And again, these numbers line up fairly well, 78% owned, 21% rented of the properties so far that we've visited. And that lines up fairly well with the census, the last census data as well. So now just to start looking at a few of the preliminary results from the work that we've done, I'm going to focus in on organic matter because it seems to be very relevant to soil health. And so soil organic matter against the use of organic amendments, we can see here from the sample size of just under 700 sites so far that we've sampled, that we do have an indication of higher organic matter content in soils where organic amendments are being used. It's a significant finding. And to turn that into something that's maybe a bit more practical, based on some other work that's been published, that difference of 0.6% organic matter could hold about 15,000 more gallons per acre of water in the upper 6 inches of the soil profile. Would also result in higher cation exchange capacity for enhanced nutrient cycling, and would also have lower bulk density and higher porosity. And we can see some of those results corroborated by the sampling as well. So we can see here cation exchange capacity in fields with organic amendments are significantly higher than those without. And we can see that the bulk density is significantly lower in the fields with organic amendments. The second last thing to show you is this organic matter by cropping system. And so we grouped kind of some of the data into what we're calling cropping systems. And so you can see across the bottom, single crop, 2 annual crops, 3 annual crops, annual cropping system with forage incorporated into the rotation, and then forage and pasture. And you can see that the last two have significantly more organic matter, about 1% more than the other systems. There's no difference right now in this kind of half of the data that shows any difference between the annual cropping systems themselves. The last thing that I wanted to show is also some interesting stuff that we can look at in terms of comparing our data to some of the metrics that are in the Soil Health and Conservation Strategy that was published a couple of years ago. And so when we look at some of the texture information and we group our soils by texture, and then we look at organic matter content, we can see that based on the targets and based on the sampling we've done so far, that we're below our targets in terms of organic matter content in the sandy loams, the loamy soils, and the clay loam soils, whereas the sandy soils and the clay soils were right on target. So this was just kind of a high overview of some of the initial results, and now I'm going to go over to Carrie.
Great, thanks, Dan. And this is such a collaboration that I'm going to trust Dan to change my slides. So today, I'm really excited to talk to you about the University of Guelph's role in this topsoil sampling program. This has been a fun project for us because we don't usually get to work with all the soil scientists in the department, and beyond that, we don't usually get to work on the exact same soil samples. So it's been really fun to get together with this group of scientists and think about what we can do. And we got really excited about the OMAFRA project and recognized the value of this incredible data set, sampling soils across Ontario and having this baseline information is really great. And so we wanted to think about what value we could add to that. And so, oh, Dan, go ahead. I'm turning the slides here by myself. So what we did was come together and just brainstorm what kind of specialized analysis that we could add to the sampling and analysis that OMAFRA is doing in commercial labs. And so my role in this is looking at the soil microbiology and working with Laura Van Aert, who's looking at microbial respiration. We also are looking at, John Lozon is looking at total sulfur in the soils. Paul Veroni and Adam Gillespie are looking at organic matter characterization and the carbon analysis, so mineralization and oxidation and active carbon. Richard Heck is doing a magnetic susceptibility and also CT scans to look at aggregate and pore structure. And Nassim Biswa is looking at a spectral analysis of the samples and digital imaging and wet aggregate stability. So on all of these samples, we are going to come up with all of this extra data and then hopefully bring it all together and see if we can contribute to the database and the known and be able to map some of this specialized analysis that we're doing. Okay, Dan. So the one thing about working with all these soil scientists that's unique, so there's seven of us, and what that means is that we need 6 different subsamples of soil. So the OMAFRA collaborators need to come up with 6 different subsets of soil to come back to the lab. And so what that means is that we send them out there for my group with nitrile gloves and ethanol so that they can sample and not cross-contaminate the samples. And then they also subsample in the field. They take 2 different soil cores for bulk density and aggregates and CT scans. And the rest gets brought back as a bulk soil sample and split up and air dried, ground, and sieved. And so a lot of summer student time and a lot of time in the last couple of years has been in the basement doing a lot of sieving and grinding for all this analysis. Okay, next. So the first analysis that has been done so far has been the microbial analysis in my lab, and that's because we need to work on fresh soils. So we meet up with the OMAFRA team and immediately do DNA extractions on the soils within a few days of them being sampled, as close to a few days as possible. And then another sample is sent to Laura down in Ridgetown, and she dries it and does Sylvina and Slan tests, so kind of typical soil health tests. And so this analysis has been started, and so we have a little bit of data. Okay, thanks, Dan. So my interest is really looking at the soil microbiology in this data set, and that's because we know that the microbial population will differ. We do a lot of studies looking at how cropping systems differ based on diversity. So we know in field trials that if you increase plant cover or you add different carbon or nutrient inputs, you can change the microbial population. But we also know that changes in soil environment, such as porosity and water content and temperature and pH, also are huge drivers of that microbial community. And so that interaction between the management practices and the soil properties is harder to study. And so this data set that goes across Ontario, goes across Ontario is really important to look at to understand those properties. And the reason we're interested in the microbes here is because they play such an important role in providing resilience and stimulating growth of plants. So they have different microbes will provide important roles in nutrient acquisition and disease suppression and stimulation and abiotic stress tolerance. And so the more diversity you have in that population, the more chance that you're going to have those important functions in your system. So we're really interested in looking at that. Okay, Dan. So the methods we're using, the first thing we're doing is just a fungal bacterial ratio, and this is commonly talked about when you think about soil health. So the idea is that increased fungal bacterial populations is sometimes considered good for the system. And so that's the first thing we're doing, is just doing a ratio. So the first two figures here just show increase in fungal population if you compare the soil with the bacteria and fungi, and the top one is more bacteria and the second one is more fungi. What my lab is interested in, and once I want to remind you, is that the two bottom, the second one and the third sample here shows that the fungal bacterial ratios of the bottom two are exactly the same, but the diversity is very different. So if you just look at the color and assume that that's a different species of microbe, you can see that diversity increases in the bottom sample, but the fungal bacterial ratio stays the same. And so we really are interested in the microbes that are there and the diversity. So next. And sometimes the diversity is actually not the only thing that we are interested in. So we've done some work in some long-term studies at Allura, looking at, this was Bill Dean's trial. So after 37 years of crop rotation, looking at increased diversity in a corn-based system, and under till and no-till. So Dan, the next slide, please. And we know in this system that corn yields are more stable in the diverse rotation. We also know that there's improved soil structure and tillage in the no-till system. And when we looked at the microbial communities in that system, we see in the left that that's a measure of diversity. There's actually no significant differences in diversity across those rotations. So we do see a tendency in the no-till system to have higher diversity with increased plants in rotation, and in the conventional system, we see a tendency towards lower diversity, but there isn't actually any significance. So what we need to do is do an analysis that we see on the right, where we look at community structure and composition. And what this shows is the tillage and the no-tillage systems have completely different community structures. So that means there's different microbial communities present in the till and the no-till system. And if you look within the rotations, you see that there's a shift in the types of communities present in the corn monoculture compared to the other rotations, with the corn alfalfa rotation being the most different compared to conventional corn. And so what that tells us is that we need to do more than just a snapshot on diversity. We need to kind of dig into what microorganisms are there. So next. So we have some very preliminary results. I have coursework master student Jordy Kane, who worked this fall collecting some data for this. And so we started looking at bacterial and fungal populations with qPCR, and this is just looking at how slope and cover crops, this is a subset of the analysis comparing cover crop and no cover crop without any organic amendments. And there's a few differences here between treatments. So next. One thing we do see is tillage frequency. In the no-till, both bacterial and fungal populations are higher. You can see there isn't much difference over time. There's some interesting results in the tillage frequency over 5 years. So the 10 to 15 passes means 2 to 3 a year, isn't very much lower. There's not too much differences here. Next. The one thing we do kind of see is that in fallow, so if there's no crop present, we do get a decrease in both bacterial and fungal populations. So that's expected but interesting. And also we see higher fungal populations in corn when corn's present. Okay, next, Dan. So the reason that we're interested in these bacterial and fungal populations is first because they affect the plant growth, but the other thing it's important to understand bacterial and fungal populations because they're really at the base of the soil food web. So they're feeding on plants and organic materials, and in turn, they're feeding into this full soil food web of biodiversity. So if we shift these bacterial and fungal populations, that means we're shifting, it has cascading effects up this soil food web. And so next, so hopefully we can use this data to help with understanding our soil biodiversity. And World Soil Day this year is keeping soils alive by protecting soil biodiversity. So hopefully that's the role that we can play.
Thanks so much, Carrie. And Dan, if you want to come on as well and unmic yourself or ask questions. We got some questions here. If anybody wants to add any other additional questions into the Q&A tab. We're not taking hands up. We're not so please add your question. We do want to hear your question, and we're keeping the questions and sharing them if we don't get to them with the researchers afterwards. But please, first question is from Graham Gilchrist. Is there enough data to create a change in soil organic carbon market-based instrument? Hope that means something to you, Dan.
I would say that our sample size is, I would consider our sample size to be fairly small, and I would say if we were to talk about any of these types of market-based things, that I would have to consult with or the team would have to consult with some economists maybe at the university before we could I would venture to comment on something like that.
Okay, thanks. The another question is, which labs did you use for soil testing? If you use more than one lab, how did you ensure comparable results?
So from OMAFRA's perspective, our samples are all run through the same lab. So we use Lab Services Division, which is right beside our building, part of the University of Guelph.
And for the University of Guelph, each of the analysis are done in the same lab. So all the microbial analysis is done in the same lab, and each PI has their own responsibility for all of the samples.
Great. And then are you collecting AP depth while sampling?
Yes, we are. Yeah, I didn't show that data. There's a lot more data that I'd love to share with you, but we just couldn't today. But yeah, no, we did. We see what the data suggests is that there's a thickening of the A layer, the AP horizon, with landscape positions. So in lower slope positions, we tend to have thicker topsoil, and in upper slope positions, mid slope positions, we tend to have thinner topsoil, which I think confirms what we already suspect and know of those soil landscape relationships.
I'm going to carry this a question for you, and I'm actually hopping to the chat line, which I said I wouldn't do, but I am. So the chat, it says, do you have the data on fungal bacterial ratios in forage versus annual crops?
No, not yet, but we will. One of the things that we did, because it was a really small master's project that we started with, we had the question of how do cover crops affected, and so we by doing that subset, we also steered away from any manure application, and so that tended to skew our results. So we don't have a lot of forage samples that have been analyzed yet, but we're working our way through it, so we definitely will.
So stay tuned. And Carrie, there's another question. What is the significance of different community structure?
So community structure is just a way that microbiologists like to talk about who's there. And so the significance is that different microorganisms play different roles in the soil and have different functions. And so if the community structures changes, that means there's different types of organisms in that system. And so that might mean that there's different functions that those organisms are playing. And so there could be different effects on your crop or on soil resilience. So it's really a way of saying, what does the population look like? Who's there?
Okay, these are questions that are like, flying at you. So here's some more.
bring it on.
Okay, how much is the microbial community relying on synthetic or organic nitrogen supply from the farmer, and how far does that affect soil carbon turnover and sequestration? And this could be both of you, either of you answer this question.
I would say from our results, we are not sure yet. It's hard to distinguish how much the microbial community feeds on the plant material versus the cover crops versus any kind of nutrient input. Yeah, we are not sure about that yet.
Dan, did you want to add anything, or? Yeah.
No, not on that one. No.
No. Okay.
Thanks,
Okay.
Karen.
I've got, there's 3 questions left, and I don't know if any of our buddy wants to vote them up and let me know which one I should be asking next. Otherwise, our buddy Keith Reed is going to get the question. Oh, Keith, what happened to your question?
Oh, I answered it. Sorry, I'm also answering to the questions that don't get voted up, because everyone deserves an answer.
They do, but don't confuse the host. Okay.
So Keith was asking if CEC was calculated or measured, and I said calculated as the sum of cations, or if it was actually measured. And I said that I'm pretty sure it's measured, and the cations are done separately. But I would have to confirm by reading the SOP from the lab again, just to make sure. Okay,
so then we seem to have. I think we're going to try to answer both these questions. We may not end up having our break, but just so, are you able to compare the new soil inventories to the historic soil reports, at least in a qualitative way?
We could, but I'd be very careful how we would do that. I mean, that comparison, just because the soil survey reports would have been the data that's in the soil survey reports were basically a quantitative analysis of many soil profiles that were used to give kind of a range in soil properties. And so doing a comparison back to those would be fairly difficult. We would have to do it, but with great caution.
Okay, and then and Carrie, I figure you'll jump in if you want to add anything, but I'm going to move on to Ruth's question. Did you consider comparing the field results to unmanaged areas such as a fence row to provide more depth to understanding the capacity of the soil and the management impact?
No. So the focus for the work that we decided was going to be to focus on the agricultural landscape without a control or a check. I think we could certainly add that later on, but we did on purpose to mask out areas of forest and wetland, to focus more on trying to get as much sampling done to give us a representative sample of all of the various agricultural soils across the province, because that's what we're really trying to build, is a better understanding of the managed soils. But yes, adding a kind of a check would probably be something that would be worthwhile that we could do in the future.
Yeah, Dan, we can do all the forest soils in Ontario after this.
So, wow, I mean, that's been a really amazing hour of 50 minutes of presentations. I want to say thanks to Dan and Carrie, and also to Aaron and Richard, because this is the kind of what Jay mentioned, the diversity of this topic. It's very integrative. You've got the soil systems, you've got the soil biology, chemistry, and physics, and you also have the people aspect to the soil health. So if nothing, complex system that we're trying to deal with. So thank you guys both for your presentation. It's been fast, but thank you so much. And we're going to actually not take a break. We're going to start again. Well, we're going to start again in 2 minutes. So in that meantime, yeah, I'm going to ask you to make sure you're aware that we have this extra web page that I put into the comments, the chats. And the chat, it talked about other resources we have. We weren't able to have all the researchers we'd like to present today because of wanting to make this a doable timeline for people. And we thought having a 3-hour session on a virtual world was enough, that we would not try and tax everybody too much in this crazy world that we're in right now. So please go visit those resources. There's videos, there's a presentation by Angela from OSCIA about the on-farm program, which I'd really like you to see at the demonstrations. But right without further ado, I hope my colleague Cam is ready. Part of this work we've been doing to put this event in place is to work in conjunction, obviously, with Soils at Guelph, as well as with our colleagues in the U of G Alliance, and with the KTT team there, and with Anne Verhalen and Daryl Finnegan and others, and Nicole Rabe in the ministry to try and create this event today. So thank you so much for being a part of it. Cam, if you wanted to turn on your camera and your mic, then we can get you ready to start your third session.
Ready to go.
You're ready to go. Perfect. It's nice to see you there. So I'm passing my hostess duty on to Cam as part of our partnership. We're working together, and you see all these partnerships happening, the work that Carrie and Dan are doing, partnerships all over the place. So I'm handing off the baton to you. So it's over to you. Thanks so much, and thanks for letting me be the host for the first 2 sessions of this event.
Absolutely, thank you. No, it's excellent to be able to collaborate. So welcome everyone to the third period of the 2020 Soil Health Research Forum. It's been awesome so far. I hope you've been enjoying hearing these presentations. For those of you who don't know me, my name is Cameron Ogilvie. I'm the Knowledge Mobilization Coordinator for the Soils at Guelph initiative, and so I'm going to be your host for this final section. We're going to dive into evaluating the impact of best management practices on some environmental indicators. As we've kind of been talking about through the course of this afternoon so far, there's real impacts that happen at the farm, but we're going to hear also now about some things that go beyond the farm, societal impacts. And I think you're going to be really excited for our next 3 speakers. They're going to take you on systems-based research projects from plot scale down to meter squared scale, all the way up to landscape and farm scale, and looking at projects that are just a few years old and some that have been going on for decades. So without further ado, I'm going to turn it over to Laura Van Aerd, who is a professor of sustainable soil management at the University of Guelph Ridgetown campus. So feel free to take it away, Laura.
Great, thanks, Cam. I really appreciate the opportunity. Yeah, so I've been interested in best management practices and soil health, and have been collaborating with researchers at the University of Guelph and with OMAFRA. And I'll just advance my slide here. Oh. Well, there we go. So if we think about sustainable soil best management practices, they've been mentioned already today. Here I've got 6 of them listed. There are others such as windbreaks. You could put in a vegetative strip to prevent erosion. But I like these 6 best management practices because they focus on protecting the soil. They also contribute to gains in soil carbon, gains in soil organic matter, and minimizing those losses of soil organic matter and soil carbon. And so if we take this as kind of building blocks, I had this question, and others have wondered, you know, what if we do more than one? What if we're doing 2, 3, maybe 4 different best management practices? Do we get a synergy? And so to answer that question, I went to Alora, to the long-term tillage and crop rotation file at Alora, which Dr. Bill Dean is involved in. And so with that system, we've got no-till and conventional tillage. I've got written here complexity in terms of crops and animals, but at Alora, we're talking about crop diversity. And we have to be careful when we talk about crop diversity. I think it's more than just the number of crops, and that's why I've put complexity. It's about who's there, what are the species that are there. And in Ontario and in the Midwest, it's adding small grains to the rotation, really has a strong influence on soil health. And then we have cover crops, and in terms of continuous living plants, we can include alfalfa as perennialization. And when we collected soil from the top 15 centimeters at Elora and our different plots, we see, no, there wasn't a synergy, but there was a positive effect. So the more of these best management practices that were employed, the greater the soil health score. And this is a significant relationship, positive relationship. Similar response was also observed at Richtown in the tillage and crop rotation trial. So my interests lie with cover crops, and I've got a long-term cover crop trial that was established in 2007. And this cover crop trial, you can see on the right-hand side, it's a mixture of processing veg and grains. And over those 8 years, we were able to plant cover crops 6 times. And so after planting cover crops 6 times, we saw increases in soil health, increases in soil organic carbon. And those are quite significant. Now, over the 8 years, and Richard Vine talked a little bit about this or alluded to this, when we look at those 8 years, we do see a 4 to 11% increase in crop yields and a 5 to 9% increase in partial profit margins. Now we have to keep in mind that in this crop rotation, we've got 2 years of processing tomatoes, and the profit margins with processing tomatoes are the main drivers in the profit margins shown here. But over the 8 years, we're showing positive profit margins. So with that increase in soil organic matter, that led us to question, well, if we're improving soil health, can we improve plant health? So in my long-term experiment, it was 4 years after we quantified increases in soil health, we were planting tomatoes again. And so the hypothesis is, can we detect differences in plant health? And we did observe differences in plant growth. So in the no cover crop, which in this photo is to the left, we saw greater defoliation, greater incidences of disease on the fruit, greater maturity in the no cover crop compared to the cover crop plots. Now I have a graduate student who is working on trying to figure out, does that relate to nutritional differences in the fruit or the fruit quality? But we are seeing that the cover crops, and I think it's resiliency, the cover crops are affording resiliency and increasing plant health. The other thing that we're starting to do is to scale out. So the Grain Farmers of Ontario encouraged me to collaborate with Dr. Josh Nazinski, and he's put out trials at New Liskeard and Winchester. We've got a triplicate site at Richtown campus, and we're looking at management of cover crops. So kind of answering those logistical questions about how do we minimize risk with those cover crops. So no-till versus strip tillage, species diversity, termination, and looking throughout the province. And so quick overview of my research. I have to say that it does not happen without funding support and collaboration. So great, I see you're there, Cam. I'm gonna stop sharing. We're gonna move it on.
Yeah, I'm gonna ask a question to you, Lauren, or
yep.
unless Claudia's good to go here. But actually, Claudia, while you're getting your slide set up, so all you folks know, we're going to kind of stack all the questions towards the end. I'm just going to ask a question in transition here, Laura. Ruth Knight is wondering, is there a soil health practice that's paramount or essential as a building block for others? Are they complementary or like forages versus tillage?
Yeah, I guess if I don't know that I could say one versus the other. I like to think of it as a pick and choose what works in your system. And if if growers can do that and build confidence in one or two of these things and then can build on, I think that's the great approach.
Excellent. Thanks, Laura. Our next speaker is Claudia Wagner-Riddle. Claudia is a professor of agri-meteorology in the School of Environmental Sciences at the University of Guelph. So welcome, Claudia.
Great, thank you. And thank you for having me. The previous speakers have set up really nicely the theme of these sessions. I'm going to kind of zoom in into one particular question. So if you've heard from Laura how soil health can be improved by diversified rotations, by stacking different practices. My research is interested in looking at the environmental nitrogen losses from these systems, in particular nitrous oxide emissions. Nitrous oxide is a greenhouse gas. So we're interested in this sort of general question, are nitrous oxide emissions or are nitrogen losses minimized when soil health is improved? So the research that I'm going to talk to you about is conducted or was conducted at the same site that was already mentioned a number of times here, which is the long-term crop rotation and tillage trial by Dr. Bill Dean, which was started back in the 1980s. And here are the details of the different crops that are grown in each year. And we conducted these measurements in 2018 and 2019, so year 3 and 4 of the rotation. But because there are 2 phases of each crop rotation, we were able to sort of get the 4 years within that 2-year period. So this was part of Pedro Machado's PhD thesis, and he conducted measurements in the simple, what we're calling the simple rotation, which is corn, followed by soy, and the diverse rotation, which is the 2 years of corn, followed by 1 year of soybean and 1 year of winter wheat plus red clover. The measurements of these emissions were done with a soil gas chamber method, where a collar is inserted into the ground and then a cover is put over it and sealed, and then samples of gas are taken manually after a time period. So that increase in concentration gives us how much was emitted. We paired this with 15 nitrogen, so an isotope tracer experiment, where the residue from the previous crop was labeled, both the above ground and below ground. And the N2O was determined, sort of the 15 N2O was determined in collaboration with University of Saskatchewan researchers. And with that, we could tell how much of the N2O was coming from the crop residue and how much was coming from the soil nitrogen or from the fertilizer. Some of the work has been published and some of it has been submitted. So here's just a view of, we did this measurement year round, both so the post-harvest, over winter, spring thaw, and then in the growing season. And here's a picture of Pedro, a happy camper, doing some measurements out in the field. So I'm really just presenting kind of the overview main result from this research, which shows, and this comparison of diverse and simple rotation. So first of all, over the 4 years, so adding up all the years of corn, soy, in the case of the simple rotation shown here as S, we get an emission that's just shy of 8, and for the diverse, it's just above 8. This has now been scaled already, but by the N input. But before we did that, the diverse rotations actually emitted more N2O because, well, one of the main reasons we find is that with that extra winter wheat in the rotation, additional fertilizer is applied. So that's why when we scale it by the N input, the differences become not significant. The main source for that N2O was either the fertilizer input or soil nitrogen. Those were the two main sources, mostly soil nitrogen. Crop residues contributed very little to the emissions. This has implications for numbers used in the national inventory, but I'm not getting into that right now. What we find is there is no difference between diverse or simple in terms of the contribution from soil or from nitrogen fertilizer. There is a very small difference between the contribution from crop residue, but basically it's comparing nothing with less than nothing in terms of the contribution from the crop residues. We were a bit surprised that the N2O emissions were actually as close as shown here between the diverse and simple rotations. But this could be related to the higher abundance of genes that associated with complete denitrification. So in collaboration with Carrie Dunfield, one of her PhD students, Nicola, did the microbial communities work on these plots, looking at the nitrogen cycling genes. So that is a potential explanation, but the bottom line is that at least for nitrous oxide emissions, we don't have the negative impact that we thought that perhaps diverse rotations would have. The next step, of course, would be to try to employ practices that reduce N2O emission. And we've done a lot of work with fertilizer practices like the 4R practices, showing that, for example, the use of inhibitors does have a significant impact in reducing emissions. So we're interested in kind of combining this with some of these soil health practices, but we don't have results on that yet. And just adding some work done in the soil lysimeters, we did see a significant reduction of nitrogen losses in the form of nitrate through the use of cover crops. And I see Cam is showing up, which means that my time is up. And I just want to acknowledge all the funding and researchers that collaborated on this. Thank you.
Wonderful. Thanks so much, Claudia. Just as we transition to Maren here, Claudia, could you answer a question from Ralph? Ralph's just wondering how many kilograms of N per hectare were applied in each rotation? And just kind of wondering, would lowering the nitrogen rate have an impact on the results that you saw?
Yeah, so that is kind of was alluding to what we're starting to look into now. We're actually working on a proposal on this, but is the fact that if these diverse rotations improve soil health and nutrient cycling, we should be able to reduce the nitrogen inputs, which wasn't done in the long-term plots. So that then has potential to bring sort of the win-win within the N2O losses as well.
Great, great. And we're going to transition to Maren McRae, and then we're going to come back and have a bit of a discussion with all three of them at the end. But Maren, I see you're ready. Why don't you take it away?
Great. I'm just going to share my screen.
I forgot to introduce you as well. Maren, for those of you who do not know, is a professor in the Department of Geography and Environmental Management at the University of Waterloo.
Great. And can you see my screen?
Yeah, it's great.
Great. Okay. So thank you. So in terms of who I am, as Cam mentioned, I'm at the University of Waterloo, and my slide just advanced without my actual advancing it. I apologize. So the work that I do is really where management practices, where hydrology and water quality meet, and what we can do with management practices to modify those relationships. So some of the first things that we had been doing as of late is really how and trying to understand and quantify how and when are water and phosphorus leaving fields, and does this vary across Ontario? And so we've certainly heard about tile drainage, we've heard about surface runoff, and we looked at over multiple years, we looked at water losses, and we found that in tile drain landscapes, most of the time, water was flowing below the ground with tile drainage, and only a small amount of annual water losses actually happened above the ground. But when we looked at our phosphorus losses, we actually found that there were different patterns, and it depended on where you were located. So once we were down in the clay plains in Essex, we found that the phosphorus losses in tile drainage were kind of comparable to the water losses. Except with total phosphorus, we did see a little more erosion in the surface runoff. Whereas when we got into the rolling topography in Midwestern Ontario, we found actually that this very small amount of surface runoff actually accounted for a lot of phosphorus losses. And so that helped us to try to tease out the tile drainage story in terms of understanding the relative role of tile drainage in our phosphorus story in Ontario. And not only that, but we looked at when these things were being lost. And what we found is that most of our losses were associated with peak flow, in particular during the non-growing season. And so most, especially snowmelt. So really that tile drainage can kind of happen throughout the year, although most of it is happening between October and April. But surface runoff, you can have it during the summer months, but more often than not, it's really associated with that primary snowmelt event in Ontario. And so when we start to think about how we can manage phosphorus and keep it on our fields, we have to remember that are we prioritizing the surface, subsurface, and where does season come into things? So from there, some of the work that we have been doing has been looking at how conservation practices impact phosphorus losses at the edge of the field. And some of the questions that we have looked at have been with regards to phosphorus application timing. And so crop rotation is going to obviously come into that, because when we start to go from, say, corn soy to a corn soy wheat rotation, a lot of the farmers that we were working with were using when they came out of winter wheat, that was associated with their primary phosphorus application. And so that allowed us to get phosphorus on the fields earlier in the season, which is useful. We also looked at subsurface placement and soil test piece. So very much managing the supply of phosphorus. And what we actually found is that, and this is in Ontario, but people have seen it elsewhere as well, essentially the more your soil, higher your soil test P is, the more your phosphorus losses are going to be. And we see this both in the surface and in the subsurface. But we also looked at subsurface placement, because again, surface phosphorus concentrations are not the only thing. There are other factors at play. So we looked at subsurface placement relative to a surface broadcast, and we actually found that placing phosphorus in the subsurface substantially reduced phosphorus losses in tile drainage, and that was because essentially you're disconnecting the phosphorus phosphorus supply from the primary pathways, which are these blue stained, these blue dye patterns show preferential flow through the soil profile, and that's where a lot of the phosphorus moves. And so we have really been using a whole bunch of different processes, different experimental methods and field monitoring to try to understand surface and subsurface losses, also the importance of environmental conditions, so soil moisture, or whether it's frozen ground or thawed ground, and just different approaches to describing what's going on. We've also looked at erosion control measures. So some of the earliest work that we did was tillage. And so a lot of the work that's coming out of the southwestern end of Lake Erie, certainly in northwestern Ohio and areas around there, is that there have been, there's been some suggestion that in no-till landscapes that phosphorus losses and tile drainage are enhanced. And certainly they're seeing that at some of their sites. But when we did some work in silt loams and sand loams in Ontario, we looked at fields at tile drainage when they were both in a rotational conservation till, and then we tilled up one of the plots. And we found that it really didn't do anything to what we were seeing in tile drainage. If anything, you maybe saw a little bit more particulate losses. So it told us that tillage was not going to behave the same way everywhere from a water quality standpoint. We also looked at cover crops. And so cover crops, while they can be advantageous for soil health, what we know is that in certain winter climates, freeze-thaw processes can actually release phosphorus to the runoff water. But a lot of the evidence for that has been from more severe climates, such as the Canadian prairies and the Nordic countries. And so we looked at some freeze-thaw cycles, and we looked at a range of cover crop species, and we found that frost intensity mattered. A Winnipeg frost versus, say, an Ontario frost, where you might have a very good snowpack to insulate those plants, you are not seeing the same winter phosphorus losses. So the risk depended on where you lived, but the risk also differs with cover crop species. So this tells us that we can optimize what we plant to try to mitigate those losses, to achieve the benefits without the trade-offs. We also found that the amount of water extraction around the cover crops was important. So sometimes in fields where you have this standing water during the snowmelt period, the crops that are growing in these ponding areas are much more at risk for phosphorus losses than species that are maybe planted elsewhere. And so people may optimize where they plant or what they plant, depending on the site-specific hydrology of their fields. So some of the work this is just some of the work that we've been doing to date, but what we're trying to do in general using these supply and transport BMPs is to try to understand, to classify regions within Ontario and other watersheds besides the Lake Erie watershed that in terms of phosphorus mitigation regions based on their site-specific climate and hydrology, and also incorporating riparian and in-stream process and watershed processes. And I would like to just thank some partners and funding agencies for being a part of all of the work that we've been doing, and thank you.
Thank you, Maren. Thank you so much. We're going to invite all of these panelists back up, Maren, Claudia, and Laura. We've got a few questions here already, but just want to encourage everyone once again to feel free to send your questions into the Q&A. We've got about 10 to 15 minutes here for kind of an open discussion between the three of them. So send your questions in. Want to jump in kind of this first question because I think it was prompted by the last slide you shared, Claudia, but I'd love to see Maren and Claudia and Laura, feel free to jump in on this too. When we talk about lake eutrophication, we try to link this more to phosphorus pollution. But this question from Rajib is wondering, is there a role of nitrogen as well in eutrophication and harmful algal blooms in lakes? Maren, Claudia, one of you want to tackle that first?
Yeah, definitely. So, yeah, we see a lot of we can see surface losses, and nitrogen is like a big factor in deteriorating water quality. So I don't know if Maren is the water person here, but we can jump in.
I think I think that they're both important. Certainly phosphorus is what they're finding is the limiting nutrient in a lot of these inland freshwater bodies, like Lake Erie, Lake Winnipeg. And certainly once you get down in the Gulf and Mississippi and whatnot, they're more interested in nitrogen. But nitrogen and phosphorus together are certainly important, because although phosphorus is going to obviously drive the productivity, nitrogen and phosphorus and their stoichiometry can also impact the types of organisms that you get and the specific organisms in those blooms, which is obviously going to be really important.
Interesting. Okay, question here related to cover crops. Do cover crop mixtures make a difference in the phosphorus release compared to just a single cover crop species?
We looked at cover crop mixtures. So the graduate student who was working with us, James Kober, he looked at cover crop mixtures, and we did not see a substantial difference in the field season that he had for phosphorus. I can't comment on nitrogen at this time. Maybe Laura can for...
Yeah, not specifically in terms of nitrogen. I think the thing to consider is, does your cover crop winter kill or does it overwinter? Because that had a big influence on release of phosphorus from the cover crop tissues. The other thing to keep in mind is just because it's released from those cover crop tissues doesn't mean it's leaving your field. And so, like what Marin's research was showing is that the soil has a great capacity to absorb the phosphorus release from cover crop tissues, and it matters on the pathway of water flow. I don't know, Marin, if you wanted to expand a little bit.
Yeah, no, that's great. Thank you. It's just the joy of being on a panel. Things don't always come to your brain. Yes, so when we had done some research at the edge of the field, we looked at phosphorus losses. And so we looked at the cover crops themselves, the residues, but also, so that was Tatiana Lozier, a master's student, and James Kober, another master's student, looked at cover crop mixtures. And the reality is that in both of their studies, despite the fact that phosphorus was released from those plants, it really did not affect water quality at the edge of the field or in the subsurface, because the soil itself had this amazing ability to pull that phosphorus out and hold on to it.
Yeah, so if we're thinking about best management practices, then really it's about protecting the soil in terms of phosphorus. Cool.
And I know, I mean, the question wasn't related to nitrogen and nitrous oxide, but you know, the hypothesis is that they would also, mixtures would also reduce N2O emissions because of the more balanced sort of C to N ratio mixture. So you can have some immobilizing and others releasing. So on the balance, it should be better for reducing N2O emissions, but we're still working on those measurements.
Yeah. You know, a word that all three of you have mentioned, and I think it's been mentioned multiple times in this afternoon so far, is trade-offs. There are trade-offs, and so there's kind of another question here related to soil type. Claudia, kind of wondering if you would expect to see different results on different soil types, but maybe all of you can kind of get into what are the trade-offs that you see with these best management practices?
Yeah, so definitely for sandy soils, we don't see a lot of N2O emissions, but potentially more nitrate drainage, right? Nitrate leaching. So that is a trade-off between two different pollutants. And then there are trade-offs in terms of yield or other, and I'll let Laura jump in, and Marin.
Don't everybody go at once. Yeah. Go ahead, Marin.
Sorry, so
Oh, that's okay. I'll jump
Thanks.
in. Yeah, I guess when I think of trade-offs, I think of, you know, how. So you have to make a management decision, and as a farmer, right? And the social science research says that there's risks. So how do you minimize those risks? And what are the risks you're willing to take, and what are the risks that you're not willing to take? And so when you think of trade-offs, it's, in my mind, it's about balancing the risks. Regardless of what management practice you're going to adopt, you need to think of the whole system. And that, in my mind, is the value of the long-term plots at Richtown and Elora that are looking at tillage and crop rotation, right? Because you have many different systems, and you can answer those questions. Well, what if we did this but not that, because of the different combinations that are available? And if you consider about minimizing nutrient losses or erosion losses, I think you want to consider that it's about keeping the soil in place.
And I think, yeah, I would agree with everything that's been said. And I think it's true, trying to understand the trade-offs is important, but it's also looking at where we have coupled benefits, where we have cover crop, or not cover crops, excuse me, but conservation practices that don't necessarily have trade-offs, but are a win on all of these things. I mean, these are the ones that we want to focus on and emphasize. Where there are trade-offs, like Laura's saying, if we can do some research to understand why those trade-offs exist, or if there are little subtle things that we can do in the practices that would offset those trade-offs, so that you don't necessarily have to have something be a clear trade-off between different things. And I think that forums like today and more information exchange where we can look at these things from all of these different angles is a really great start, a really great step forward, and some more collaborative research projects to look at these combined things, I think would be really advantageous.
I love what was the term you used there? Coupled benefits? Was that what you said? Yeah, I really like that idea. I'm wondering, maybe as we kind of wrap up this section, all of you kind of looked at cover crops or quote unquote perennializing rotations. Is that a win-win? Are cover crops a win-win for the environmental benefits, or maybe do we need to get a little bit more specific within cover crops about certain types of management and certain cover crop choices to have it be a win-win?
I'll go. I think they're a win-win, and they are a management challenge. So they add complexity to your system, but that also adds complexity to your management. And so if we think back to Dr. Arbuckle's first comment, it's those systems-based thinkers that are not just thinking about one thing. Then I think the benefits and the win-win of cover crops come to the forefront.
And Laura, maybe you can comment too. Some of your recent research on your long-term cover crop trials have shown that maybe they're more likely to win in certain cropping systems than others.
Yeah, that's fair. So in my system, we're in a processing veg grain system. So that's very representative of the sandy loam soil that my long-term trial is part of. And, you know, if you consider the economics of processing veg versus grains, I think anyone would take processing veg over grains. Now, having said that, there's a lot more management involved in processing crops. And maybe that's part of the system. It's those processing crops you can harvest earlier than a lot of the, let's say, soybeans or corn, and you have time to get a cover crop into the system. However, it is interesting that we are seeing increases in soil organic carbon after planting 6 times in 8 years. So you can move it, move organic matter and move soil health.
I've got a question here from Ruth Knight. And so maybe Claudia, Maren, Laura, as all of you are both researchers and educators, would be interested in your thoughts on this. I'm just wondering, how do we incorporate systems thinking into education and into knowledge transfer? Maybe Claudia, you want to start off with that?
Yeah, I think you need to have funding, like you need to have a concerted effort. I mean, in the science approach, it tends to be reductionist, right? Like to understand something better, you move all the confounding things to try to understand that one thing better. But we've had so much advancement in the last 30, 40 years that I think now is a good time to have more of that integration. And, you know, we have a program for graduate students, Climate Smart Soils, that tries to do that through courses where they get exposed to different views. So I think it's through those kind of initiatives that you move beyond the reductionist approach.
Great. Maren, maybe I'll leave the final word with you if you want to answer that question too.
Yeah, no, I would agree with everything that Claudia has said. So certainly, and just in our knowledge mobilization or knowledge translation, I think drawing in and incorporating this and why these things are working and how they have these multiple benefits. I think just the more we do of that, I think the better. And yeah, it's just education. So.
Fantastic. Well, thank you all so much for joining us. It's been great to learn about your research. I share a lot of what these three are doing in terms of the research on the Soils at Guelph Twitter, so you can follow us on Twitter. I also want to just point out that there is a Midwest Cover Crops Council conference coming up February 23rd to 25th, and I'm going to drop the link for this conference into the chat, but you might be interested in registering for this, so feel free to check it out. And now we're going to move on to the final section of today. I'm going to invite Dave Hooker on. David Hooker is an associate professor at the University of Guelph Ridgetown campus, and he's just going to finish us off today by looking into the immense value of 65 years of research on some long-term rotation and tillage trials. So thank you so much, Dave, for joining us today.
Yeah, thanks, Cameron. Can you hear me okay and see my slides?
I can hear you. I can see you. I cannot see your slides yet, though.
Oh, is that right? Okay.
I'm seeing a great cover crop behind you. Is that the field behind your house?
From last year, it is. Yeah.
Nice.
Yeah, so I'm going to try and fix my screen. I apologize for that.
No worries.
All right, so I'm not sure why it's acting like it is. It's not showing my screen or sharing my screen properly. Oh, this is embarrassing. I might have to go without a screen.
Okay.
Just a second here.
Yeah, no problem. I think Ellen, you might also have a copy of this possibly. So if Dave's having trouble.
Yeah, let's go with Ellen's copy.
Okay.
I just can't seem to get this working here.
Ellen or Tegan, if you're able to kind of throw yours up, that would be great.
Working on it.
Wonderful.
So while Ellen is getting that presentation, I just like to give I guess my I'm thankful for being plugged into this, and I've just enjoyed this forum. since 1 o'clock today, and many good speakers and topics. And I'm not going to talk about that much data today. And instead, I'm going to show off some infographics that were produced from University of Guelph OMAFRA collaboration. And I'd like to talk a little bit about those. All right, so thanks. Thanks, Ellen. So I'd like to first recognize Dr. Bill Dean. He just retired recently. And so he has managed the Elora crop rotation tillage trials for about 20 years. So just over 20 years, I believe. And he just recently retired. And he has just been instrumental in getting the message across and I guess connecting the researchers, different disciplines with long-term research trials. And Bill and I have worked together a lot, especially in the past 10 or 15 years, especially, getting funding for these long-term projects. And we sing from the same songbook, so to speak, in terms of the data. So I like to talk about 65 years of combined data from these trials, and I have less than 300 seconds to talk about 65 years, site years of data. And so this is quite a milestone, and it is from 2 sites. And so we have the next slide, the Ridgetown site. The Ridgetown site, so we have, was initiated in 1995. We have 7 crop rotations, 4 nitrogen treatments, and also 2 tillage systems. And so these projects investigate those long-term questions that we have. So it's very important, as we've, I guess, acknowledged in the past couple hours or so, just the importance of long-term data. Everybody wants to see the data, you know, in terms of making the right decision based on data. And where do we get those data? We get them from trials like these. So short-term experiments are important, but the long-term experiments are especially important, especially when changes occur very slowly over time. And so a change in a management practice might take 10 or 15 years to show that effect or to be equilibrated within the soil system. So we need to document and try to quantify that. Okay, next slide, please. And so the Elora rotation was started in 1980, and it involves a little bit different mix of cropping systems compared to Ridgetown. So 8 crop rotations, and these crop rotations involve some oats, some barley, and also forages. And so some of these rotations, of course, also involved, including the ones at Ridgetown, involve underseeded red clover as well. And both Ridgetown and Elora, of course, are 2 different environments, 2 different heat unit locations, obviously 2 different soil types. And it's just amazing that we have in our data set, we have a lot of the trends, same trends occurring at both Ridgetown and Elora. And so that's what, I guess, prompted us to make some of these infographics. So next slide, please. So this is just these are just highlights of some of the 4 infographics that were produced this past summer. And I just think these are great. So the more simple I think these infographics are, the more effective, or I guess the more effective they are to communicate some of the key findings of a very complex trial like we have in the long-term trials. So next slide, please. So I think one of the most important findings of these trials is just the impact of crop rotation diversity on corn and soybean yields. And so if you can just kind of advance that slide, I think a little annotation will pop up, that most of that increase in corn yields is due to wheat in the rotation. And so we see anywhere between 6 and 17 bushel per acre more corn, or about 5 bushel per acre more soybean, with wheat in the rotation. So a corn, soybean, wheat rotation would see these benefits to a corn and soybean in that enterprise, and it's all due to the inclusion of a small grain cereal in that enterprise. So it could vary, corn yields could go up by 15%, and soybean yields as well. And so another thing that we notice, and one other, I guess, important factor or result of these long-term trials is that we can assess the importance of weather or the weather effect over time as well. And so in these crop rotation trials, we noticed that the corn and soybean yields, that rotation effect from wheat is the greatest in hot and dry years. And so that would equate to higher income, especially in hot and dry years, compared to a more simple or more like an alternating corn and soybean rotation. And so that's another benefit of crop rotation. All right, next slide, please. And it also is makes the tillage, so the adopting reduced tillage a little bit easier. Now, this slide shows the effect of yield, but I really don't like to talk about yield alone. I like to talk more about economics. But of course, the yield limitation, maybe a little bit of a yield penalty, may be associated with reduced tillage. And so I think what we need to do, I guess, is to foster or to create an additional, I guess, incentive to adopt reduced tillage systems. We need to get that yield penalty either mitigate it completely, have it zero, or to see it as reduced as possible, because even though the economics is more important, that reduction in yield that's kind of earmarked to reduce tillage is an important factor in adopting reduced tillage as well. But we know that crop rotation supersedes any effect due to tillage. And so if you want to reduce tillage, growers want to reduce tillage for various reasons, economic reasons, reduction in soil erosion, crop rotation becomes even more important when tillage is reduced. All right, so next slide, please. So as I mentioned before, different weather effects affect crop yields and tillage effects as well. And so we want those incomes, we want those yields to be as stable as possible. When we make this yields as stable as possible, it just reduces the reliance on support programs as well. So it's really a win-win-win situation in terms of diversifying crop rotation and reducing tillage as well on crop yield stability, economic stability. All right, next slide, please. And we also see a tremendous effect due to reduction of nitrogen as well when crop rotation systems are diversified, not only because red clover and other cover crops can be included in a diverse crop rotation, but we know that if we have wheat in the rotation, it also reduces the reliance on fertilizer nitrogen in our corn years, even though that wheat is not a legume. It seems to have there seems to be a reduced reliance on nitrogen fertilizer when wheat is included in the system. So this slide, I think, is an excellent slide that shows that these crop rotation systems, a more diversified crop rotation, especially ones that include small grain cereals, allows the integration of cover crops, and the adoption of reduced tillage system changes the soil. And these changes in soil has been shown or linked to increases in yield, increases in more stable yields as well, increases in dry yields in dry weather, and makes the transition to reduced tillage easier. And that is mainly due to these management changes are changing the soil over time. And I think the message is right here, I think the most important message is that growers, if they're practicing conventional tillage with a corn soybean rotation, like we have to start right now in order to achieve these benefits in the long term. And so that's the message that these long-term provides, this long-term research provides. It quantifies those effects in order to make those decisions that will benefit in the long term. All right, so thanks very much.
Thank you, Dave. I wish we had more time to go into some of those results a bit further, but I think you've summarized it really well. And yeah, I agree that that collaboration on those infographics was great. And I think they really do summarize those results well.
Thanks. Good.
Thanks, Dave. Laura, you're back on. You're going to close us off for the day. You,
I am.
provide
Thank
any
you,
final comments?
Cameron. And thank you to everyone. Wow. Wow, wow, wow. You know, Saturday was World Soils Day. Perhaps December 7th should be Guelph Soils Day. And I want to let you know that this is just a fraction of the soils related research occurring at the University of Guelph and with OMAFRA. You're just seeing a little snippet of it. So here we have the acknowledgement slides. Thank you very much, and your certified crop advisors can get that number. So today you heard about the drivers of social networks. You heard about the economic drivers as well. I learned, and I don't know why it didn't occur to me before, but that social science is a slippery science. It's a hard science. Of course, humans are so diverse. We looked at soil from the small scale, from chambers to the landscape scale. Great, excellent use of scale. I've been invited to thank everyone. So the thank yous are there from OMAFRA, from the University of Guelph. We'd like to acknowledge Rebecca Dunn and Cam Ogilvie. From OMAFRA, Ellen Gwynn, Nicole Rabe, Anne Verhollen, Daryl Finnegan, and Tegan Hunt. I was invited to give this closeout because I'm Research Program Director with the Ontario Agri-Food Innovation Alliance, not because of my contribution to this, this day. It's all about the people who are shown here on the slide. Tegan, if you could please show where participants can find more information. So in the next couple of days, I think there's a, did you have a slide? I hope there's a slide. In the next month, couple of months, there are other opportunities to learn more about soil and soil research. We have the Midwest Cover Crop Council meeting, which is in February. The, oh, Ellen's here. The Ontario Crops Conference is coming up in January. There are strip tillage events coming this month. There's lots of different opportunities to learn more about soils. And I will finally turn it over to Ellen Gwynn.
Thanks, Laura, so much. Thanks, Cam, for hosting this last session. Thanks, everybody, for attending. And thank you, everybody, for all our panelists, all our researchers who've done all the great research, the ones we couldn't feature. Thank you. The evaluation information will be sending you shortly in an email. Hopefully you caught the CSC, the continuing education information, and Verhalen is your contact as well. If you need that, please look in the chat. You'll find out some of the links to the events that are coming up. And I'd just like to bring this event to a close. I'm so glad we were able to do it. It wasn't what we thought we were going to do a year ago when I booked the conference center at One Stone Road, but it meant a whole bunch more of you could attend, and that was really wonderful. Thanks, everybody, for all the hard work that you've done to make this happen. And I guess that's the end of this event. Thanks again. Thanks, Cam, for all your hosting duties too. Take care, everybody. Happy Soils, World Soils Day.